Right, so let's finish our discussion on distributed databases. Last time we started discussing, but we were about halfway, okay? Right, so the idea behind distributed database is your database is distributed among servers rather than keeping it in one server. Okay, it can be your own server or even cloud servers, but you distribute among few or more than one clouds. Okay, so that is the alternative for having only centralized database, right? Having only centralized database, right? So remember, this is not distributed web server or something. This is about distributed database server. Okay. Sometimes this may be complemented by distributed servers as well, or maybe you have only one server, but the database is distributed. Okay. So that means we don't communicate or the databases communicate with each other rather than we let them communicate through web services and so on. So then that is not distributed database. Okay, then that is not distributed database. Right. So the advantages, obviously, when we have distributed our database, uh, the performance can increase because the clients will be connected to their nearest database. Okay, sometimes in their sites, and also better reliability because there can be redundancy, right? If particular database is down, still you may be able to auto redirect it to the next database nearer to you, right? And also its agility, scalability. So when we have more and more users accessing, you can gradually increase the number of databases. Okay. At the same time, yes, there are some challenges, right? Especially additional complexity of synchronizing these databases because otherwise there can be uh, inconsistencies. And also there's a challenge in transaction handling because you need to go for distributed transaction handling because maybe one table inside A, other table inside B, maybe this is success, this is fail. So then you need to roll back this, which is in a different side. Okay. Uh, and also security because you need to secure your data in multiple sites. Okay. And so on, right? So there are pros and cons. Right. So we can do scalability in two ways. Horizontal scalability, where you expand number of nodes. Vertical scalability, that is expand the capacity of an individual node. So we can do both, right? Depending on our requirement. And also when we increase number of nodes, right? So the possibility of network failure also increase. So therefore we must do it in a controlled manner, right? Of course, it gives you the agility so that your business can grow. And when the business grows, you can scale up your database. Okay. That is agility rather than you commit or invest too much upfront. Right. So then we moved on to the distributed database concepts. Right. The different types of distributed databases, homogeneous versus heterogeneous. Homogeneous means every site has the same database running. If it is Oracle, everywhere Oracle, which is easier to manage. Heterogeneous means maybe different sites may be having different databases also. Maybe one site Oracle, the other site MySQL or Microsoft SQL, right? So that make it even harder to manage it. Okay. But if it is something like a third-party database, sometimes you don't have much of a control, right? And also we discussed about the autonomy. Right? independence or your freedom. So the design autonomy, communication autonomy, execution autonomy, how independently you can design, communicate, execute queries, and so on. Okay. So based on autonomy, we classify them as pure distributed databases, federated or the in-between, like a federal solution in politics, and multi-databases. Okay. So in pure distributed database, there's no local autonomy. So all the database is considered as one global schema. Like local sites, they cannot modify. Okay, they cannot see it in a different way. Multi-database means you have the full local autonomy as well. So each site has their own autonomy while it act like this one database as well. Sorry, it doesn't have the global scheme. Right? Sorry for that. So that means each site has the full local autonomy, but there's no global schema, like global schema. So that is more suitable when you are more interested in localized operations. Federated systems is where you have the global schema as well as the local sites have a bit of autonomy to write their own queries, customization, and so on. Okay, so the most of the time we ended up in sort of a federated database systems. Okay. So then we moved on to allocation. Uh, so allocation is the distribution of data into nodes. Okay. So it's more physical concept. Physically, how you distribute your data. Okay. So allocation depends on your performance, availability, uh, type of transactions, and so on. So what are the three type of allocation? Centralized allocation, where all data in one site, of course, then it is not a distributed database. Partition or fragmented, where part of the data in one site, maybe another part is in another site. Okay. Uh, so maybe customer details related to Candy branch is in Candy database. Customer details related to Gold branch in Gold. If you take international example, say bank, HSBC or something. So the customers related to Sri Lanka, they stored it in Sri Lankan database. Customers related to Maldives, saved in database in Maldives, but it act like a normal single application. So that is called partition or fragmented allocation. The third one is replication. That means you keep copies of data in multiple sites. So same data can stay in multiple sites, same data, duplication. So again, the reality, you will be, of course, centralized allocation is not distributed database. In reality, you will have combination of partitioning and replication. Okay? Fragmentation and replication. So this is a summary. So I did some modification to these slides as well, just to make it a little bit more readable. Right? So these are some examples we discussed in the last class. Okay. So that is, of course, the challenges or the negative point of allocation is again synchronization overhead, because your data may be partitioned into different things, and also when you have duplication, uh, definitely you need to synchronize. Okay? And also your query handling become more complicated because your data is in multiple sites if it is partition. Okay. Okay. Security and all these problems are there. Right. So then we look at the fragmentation. Now, don't get confused. Allocation is about physically how you store it. Physically. Fragmentation is a logical concept. So therefore, these concepts are overlapping. Right. So your conceptual fragmentation will be executed as an allocation and replication. Okay. So fragmentation is the process of dividing the database into various sub-relations and so on. So that you can do it at logical level. So once you divide, of course, then we call it allocation, right? Allocation. So remember, we can do it in table level or record level. So table level means different tables in different sites. Record level means in the same table also. Remember, we can do it in two ways, vertical or horizontal, right? Horizontal fragmentation means same table, but some records in site A, some records in site B. Like customers related to site A in site A, customers related to site B. Those records in the same table, but those records in the site B. So that is horizontal fragmentation. Vertical fragmentation is obviously some columns in site A, some columns in site B, and there must be overlapping columns like foreign key. Okay? Oh, sorry, the primary key. Otherwise, you can't join them. Okay? So this is table level distribution, different tables in different sites. And record level, it can be horizontal, vertical, or mixture of both horizontal and vertical. I think that is where we stopped, right? Last class. Right. Horizontal fragmentation. So the same table, different records in different sites. Right? Something like this. Sales employees in sales table, marketing employees in marketing table, and maybe these two tables are in two different sites. Okay. Maybe they are in two different locations. Vertical fragmentation, some columns in site A, some other columns in site B, and definitely your primary key must be overlap. Both sides you must keep your primary key, otherwise you can't connect combine those again. And at the same time, there's possibility that some columns are common in both more than one place. So that is replication. Some columns in vertical or of course the primary key must be replicated anyway. And horizontal word fragmentation also there can be, right? Head office, you have all the records. So that means it's fragmentation plus replication. So when you allocate, you may use both fragmentation and replication because allocation is the physical concept. Right? So we call that mixed fragmentation. So that means we have the both vertical and now remember mixed fragmentation means we have both vertical and horizontal fragmentation. Okay? Both vertical and horizontal fragmentation at logical level. Okay? On top of that, you can introduce replication as well. When you do allocation, you may have vertical fragmentation, horizontal fragmentation, plus some sort of a replication as well. That means some records are overlapping or some fields are overlapping in multiple sites. So when you think of allocation, you need to think about all these things. Right. So this is just a mixed fragmentation, which has both uh, vertical fragmentation. That is, vertically we have fragmented name and salary to one table, one site. There you can see all the records are there, maybe head office. And then you need to give the assume name is the primary key. Then you need to keep name and department in another table, but rather than in another table, we have further break it into two tables. So that means that vertical part is right? That vertical part is horizontally fragmented again. That means we ended up in 3 fragments. But no replication here because this is not a replication. This is your primary key. You need to keep it so that you can join. So replication means, okay, maybe you are keeping another field, right? Here as well as here, same data. So then it is replication plus fragmentation, mixed fragmentation. Is it clear? Because this subject you need to understand, right? You can't memorize and pass. Now all of a sudden you will see that now the era of memorizing and passing exams is over. Right? For example, if you take data management systems, uh, data structures and algorithms, even for large extent object-oriented DSA, even web development, somewhat okay. So it's all about you understand. Okay. Right. So remember, on top of fragmentation, right, addition to fragmentation, we can introduce replication during the allocation. Right. So now these examples, there's no replication. So having primary key is not the replication. Right? So now we can introduce replication into the picture. So why do we replicate or duplicate? For performance reasons. High readability, high read performance, okay? High availability for read operations. But at the same time, it adds complexity to write operations because when you do insert, update, delete, you need to do that in multiple places. Right? So that means it increases the read operations performance. At the same time, degrade the write. Write means insert, update, delete. And also it can create bit of inconsistencies, more challenging in transaction handling. Right. So replication also we can think of 3 possibilities: full replication, no replication, partial replication. So in reality, it will be mostly partial replication. Right. So full replication means if you have 3 sites, all 3 sites have the exact copy of the data, which is very rare we do. Right. So you have 3 branches, all 3 branches have this exact database. And when there's an update or insert or some write operation here, you need to synchronize with the other. Right? Which is little bit of overhead. Okay? Which is little bit of overhead. Very rarely we go for full replication. Okay? So no replication means each site keep its own data only. Right? Its own data only. So this keep only data related to this branch. Say this database keep only data related to this branch and so on. It's sort of a now very independent databases. Okay? Say banks. So Maharagama branch keep only the data related to Maharagama branch customers. Right? Pomagam branch keep Pomagam customers details. And maybe Kadwila branch keep all the records related to Kadwila. So then someone will ask, then why do you want to connect them? So we need to connect them because someone from Maharagam branch may go to the uh, Kadwila branch and do withdrawal. So therefore that data is in here, right? So therefore still these must be interconnected, but not sort of a synchronized. So then that query must be executed here, but no replication, no replication. But this is very rare, very rare. Most of the time your head office will have some data and all these guys are referring to that. So that is where you have the mixture. Okay. Or everything is saved in the head office. or just a bit of data in your branches. Okay. So these are the pros and cons of full replication versus no replication. Of course, full replication means higher availability, high performance for read queries because your site has all the data. Okay. But degrading the write performance because when you write something, write means insert, update, delete. You need to update all the sites because each site has the exact copy. And of course, the transaction handling become more complicated as well. Complicated in the sense once you do the transaction in your site, you need to propagate it to the others changes. It's not that a transaction involve multiple sites because you have all the data, all the tables, but the result must be sent to the other sites. Otherwise, other sites are having outdated data. Right? So no replication means obviously lesser degree of availability because all the branches, all the sites depends on one site or the main site to access. And also lesser performance for read queries because you don't have your local data. You need to go to the central location and get it. So this is good if you have more writes and less reads. Okay. And transaction handling is also much simpler. Because in the exams, the questions are mainly explain it, define it, give advantages, give disadvantages. So do some calculations and solve the problem. Right. So the partial replication means obvious some data is duplicated and some data is not duplicated. So that is where you can compromise, right? Rather than compromising a lot of your right query perform degradation, you need a reasonable read performance as well as reasonable write performance. Maybe things which are very much related to you, you keep it in your site. Or at least keep duplicates in your site. That is what replication is. But don't replicate everything. Replicate only things that you need frequently. Other things, just keep it in the central location. It's all about sensible replication, sensible fragmentation. Right? Sensible replication, sensible fragmentation. That is what you are supposed to do in allocation. Okay? So get the balance between the pros and cons. And also do it as a holistic thing. Think about both fragmentation and replication together for the best performance. And think about all these things: performance, transaction, security, right? Read queries, write queries, transaction handling, security. So then you decide it. Okay. Right. So now we move on to our next subtopic. Any questions up to this point? Any questions up to this point? Because if you don't understand, you can't understand the next part. I told you this subject used to be in the final year, semester 6. And a lot of students used to fail this subject in semester 6 also. Now they have taken it to semester 3. Almost same syllabus plus additional things. Just tiny things they have removed, but for that they have added so many new things also. Right, distribution modes. I'm not scaring you, right? I'm just I want to make sure that you are up to the expectation, right? When you have enough time for the preparation, okay? Right, distribution modes. So we can consider it as single server shredding master slave replication. Now you can see a lot of concepts are overlapping. So that is what make you sometimes uncomfortable. Sometimes we look at the same thing or combining two or three things and we look at it as another concept. Okay, so therefore you need to be very careful. Otherwise, everything will become sort of a soup where you understand nothing. And again, if you have any confusions, okay, you can ask it in this class as well as have a serious chat with ChatGPT. Just tell your problem, what you really don't understand, what is really confusing you. Most of the time, I would say 90% of the time, ChatGPT will give you a very good clarification. Okay, right. So, what are three distribution mode? Single server, shredding, master slave replication. Right. So, obvious single server is no distribution, right? You just have one database. So that is just a reference, right? Of course, then it is not distributed databases. So that is easy to manage, but no scalability, no availability, and so on. So that means you don't have the advantages of distribution. But the simplicity is there. Simple transaction handling, simple query processing, but performance issues, scalability. Right? So shredding means you physically splitting your data, right, into different sites. So you can see this is pretty much like allocation, right? Allocation. Now here you need to think about fragmentation, replication. So remember, fragmentation is a logical concept. Vertical fragmentation, horizontal fragmentation, mixed fragmentation. So shredding is more physical implementation, right? Physical implementation of mainly horizontal fragmentation. Right. So when you do shredding, you need to think about the location, load balancing, and also the order of access. How are you going to do the queries? Which site you want to go first, which data you want first, then you can join with the next data. Okay. So then there's a concept called auto shredding also. That is, you give that responsibility to your database management system. Right? So it will optimize it depending on the statistics available for query executions and so on. Because your database management system has all the statistics, which queries are executed, the time for a particular execution. So then your DBMS knows which type of queries are the most frequently executed queries in your database, and which queries are performing lesser, which queries are performing well. So then using that statistics, your DBMS also can suggest, okay, let's fragment like this, let's allocate like this. So then you call it auto shredding. Especially we use it in NoSQL databases. Like Facebook, YouTube. So they heavily use NoSQL databases. Right. So these are the two type of replications: master slave and peer to peer. So master slave replication means you have two type of database servers or databases in your distributed database system. One is master, others are slave. Usually one master, many slaves. So sometimes even few master and few slaves. So the idea is all your writes are done to the master only. When there's update, insert, delete, write means insert, update, delete, okay? It's done to the master only. And master's task is propagate it to the slaves or the other databases. And slaves are used for read. So writes are done to the master, but all the reads are done from slave. So that is the idea behind master slave. Master slave. So it is the master's database's task to propagate the data into the slaves. So this makes especially transactions and so on very easy to handle because your transaction handling is all about update, insert, delete. So now those things happen in one database. There's no distributed transactions. After transaction is completed in a single database, the results are propagated. Okay. But at the same time, there can be delays when you do the read operations from the slaves. There can be delays because your transaction happened in master and then propagated. Not only delays, there can be inconsistencies. Maybe this is updated, but not yet this one updated. Mainly it is the delays because maybe you do some update, right? Say you are from Maharagama branch, there's update to the record, but the updates are not done in your Maharagama table database. Updates are done on head office, and head office need to push it to the slaves. Okay. Sometimes your local updates may not be reflected in your local read. So that problem is not there in peer-to-peer because you update your peer. Then there are some other problems. So master-slave replication is more suitable when you are having more read-intensive activities. That means you mostly read, sometimes write. Okay, sometimes write. Okay, so then you read it from your slave because sometimes only write. Most of the time you're reading, your reads are correct. Okay. So master slave replication has the advantage of scalability because it's very easy to add slaves because slaves are doing just one task, read. So this is the simpler approach. And also the read load is properly distributed and slaves only do reads, no writes. Okay. So in that kind of a situation, this is good. So what are the disadvantages? So single point of failure for writes because all the writes are done to the master. If you have only one master, if master is down, you can't do write. You can do only read. So that problem is not there in peer-to-peer. And also the replication lag. Lag means delay. Because you do the update to the master, then master need to propagate it to the slaves. There can be lags. And write bottleneck because you write only to one machine, master. So all these guys, when they want to write, they need to come and update the master, insert to the master. So therefore, if it is write intensive, right? So there's a bottleneck here. your activities are more write intensive, this is not the way to go. Okay. So be very serious, because in the exams they ask pros, cons. Right. So the next approach is peer-to-peer replication. So here there's nothing called master, all are equal level. So that means for any node you can write, you can read. For any node you can write, you can read. Obviously now the advantage is if you write something and read your data, definitely you are going to get the updated data because you write to your copy and you read from your copy. So you write and read from the same thing, same database, your local part. So therefore, for your changes, you will always see your changes. Okay. But others changes, so if you are reading others changes, there can be issues because maybe someone do the update to this, someone from say UK, but you need to wait until it propagate to your machine too. Then only when you read it, you can see it. Okay. Peer-to-peer replication. I mean the replicated part, right? So not all the data is replicated, right? So then අමතක කරන්න එපා ඔයාලා replicate නොකරපු data තියෙනවා fragmented data. ඒ replicated data එක read කරද්දී සමහරවිට delay එකක් තියෙනවා. So that delay can be higher than master doing it because master's task is propagation. So therefore master will try to do it faster. But now these are peers has to propagate it to multiple databases also. There can be inconsistencies, especially when you read something written to another site. Okay. So therefore, if it is more write intensive, so this approach is better because no bottleneck. You write to your database, no performance bottleneck. And if you read mostly your write, right? For example, you deposit money and you want to check your balance. So this is good because your updates are in your side. But if you want to check someone else data, this may not be the idea. Peer-to-peer replication. Now we only looking at the replication part only, right? Remember, while the replication is considered, right? In the parallel, you need to think about fragmentation. And you can't just think of one factor and design your database. So you need to think about the replication, fragmentation separately and together as well. So this peer-to-peer master-slave is related to replication, not to the fragmentation. Fragmentation, you don't have peer-to-peer, master-slave. So each peer node can read and peer means same level. There's no master-slave kind of a relationship, right? So any peer can read and write independent. And the peer must propagate it to other peers. But most of the time, expectation is whatever written to your database is mostly read by from your database. So these are the process of positive things. Now the write operations are distributed because earlier, remember, all the write operations were done to the one master. Now it's distributed, better scalability. Change detection, if your changes, you immediately see your changes. That is 100% guaranteed. But in master slave, sometimes your changes are also you can't see. You can see it only with the delay.
Sir,
Yes.
That means master slave is not real time.
Nothing is real time.
Okay.
It depends on your context. Master slave for your transactions are not real time. But in peer-to-peer, actually your transactions are pretty much real time because you update your database and then you read it from your database. But if you are looking for others' data, yes, definitely none is real time. None is real time. But peer-to-peer is more real time for your own transactions related to your database because your data changes are in your database or your site. So here we have the high availability, especially for write, because remember earlier we had single point of failure for write. Now you don't have single point of failure. Maybe one site is down, still all the other sites can do both read and write. So it's better load distribution because both read and write is distributed. Better fault tolerance because you don't rely on one site for write operation. And of course, there are cons as well because there's no single master who does the propagation. Now each peer need to do its own propagation. So now propagation is more complicated. And maybe transaction handling can be more complicated in some cases. If it involves like say money transfer, say your account is in X site, someone's other's account is in Y site. Now you need to update bit of your site and their site. So the transaction become more distributed if it is related to replicated data. So the synchronization transaction handling can be more complicated in peer-to-peer, but definitely higher availability, higher write performance, and so on, higher scalability. Right? So we can combine these things. Okay, we can combine. That means shredding means horizontal fragmentation, replication, that is redundancy of data. Right. Our next subtopic is transparency. This is an independent topic related to distributed databases. First of all, in IT, transparency means you can't see. I know it's very confusing. Usually, transparency means you can see, but here, transparency means you don't care. Right? You don't care. You can think of it like you can't see. Okay? I don't know why they use this kind of a convention. Okay. Okay. So here, transparency means not allowing the end users to know all. No need to know. No need to know about that particular details. You can just forget about and do your task. Then we say it's transparent. So you know that in general, if it is transparent, you tend to look at it, right? But here transparent means you can't look at, you can't see it. So therefore, you don't worry. When you see it only, you worry. So that is why I'm saying this is completely opposite meaning. Okay. So basically, here transparent means good. Why? We don't need to worry about it. Okay? We don't need to worry about it. So we can think of, or not, we can think of there are concept related location transparency, naming transparency, replication transparency, fragmentation transparency. In different classification, we have the design transparency and execution transparency. This is one sort of a classification. This is another way of looking at, whether design level or implementation level. Right. So what is mean by location transparency? Remember, you have multiple sites, right? Site 1, site 2, site 3. So when you work with your database, I mean, not the end users as a software developer, programmer, because your Java program, your Node.js program, you need to communicate with your database, right? Database connectivity. When you write your queries in your programs, right? Your PHP program, Java program, Python program, if you don't worry about the location, you just write your query. That means you just refer to a global schema. You don't say the table from site 1, table from site 2. You just say table from this particular table. So then we say that we have the location transparency. You can see location transparency means you don't care. You don't refer. But if you need to say that, okay, select all from employee from site 1, union employee from site 2, and then do this join. So then you don't have the location transparency because you are referring to the locations. So location transparency is good. That means if you don't refer to location, that is good. If you refer to location, that is bad. That means you need to worry about that. Okay. Glass is transparent, so it's like invisible. So we can't see it. I don't know. Maybe, right? Maybe like that also. Okay. I don't know exactly how they have come up with this. Okay. Maybe that is one possible uh, explanation, right? Transparent, therefore you can't see it. Yeah, maybe. Okay. So basically, when it is transparent, it is good, right? But better way to, I feel like the better way is when it is transparent, you just assume it is the opposite. You can't see it. If you can't see it, that is better. Right? If you can't see inside, that is better. So if you think of it, your database as a box, if you don't need to worry about these sites and so on, that is better. That is easier for you. If you see it and if you have to refer to it, that is a headache for you, right? So therefore, how I remember it is transparency is you can't see it. What we need is you can't see it. You can't see the inside things. Remember that is the idea behind encapsulation also, right? You encapsulate and hide the implementation. So hiding implementation is the best. So that hiding must be done by the distributed database management system so that the software developers can, their task is easier. Right. So here you can see we just say employee table. We don't care whether it's a site A employee table, site B employee table. So then this is location transparency. Right? We don't refer to the location, physical site. But if you need to refer to physical site, that means no location transparency. So then the naming transparency. Because sometimes different sites may use slightly different names. Okay. One site, it will refer to it as, say, customer. Another site, it will refer to as consumer. But maybe the both are the same. So if you don't need to refer to these differences in names, for you it's a global schema, say called one particular name. You don't care in different locations, you do use different names and so on. So then we say name in transparency. So you just refer to the global name in the global schema. You don't need to refer to the names in local schema. So then we call it naming transparency, which is good. Transparency is good. That means you don't need to worry about this because you refer to the global scheme. Replication transparency means, remember, there's a possibility of same data replicated in multiple sites. Right? Replicated data in some data, right? Not all. Sometimes, of course, full replication means all the data is replicated. But when you write your query, you don't care whether it's replicated, how many places it is replicated, from which place you want to get your data. You just refer to the global scheme. And DBMS, distributed DBMS, handle it. What is the best strategy to access or synchronize? So then we say replication transparency is there. That means you don't care about the replication. That is something the distributed database management system handle. Okay. So everywhere, if you have the transparency, that is good in general. But in some rare cases, not having the transparency give you more control, fine control. But most of the time, we better not to get that additional complexity and let the distributed database management system handle it. So basically, we prefer transparency unless there's a very good reason, very tricky scenario that you need a bit of more control. Right? Fragmentation transparency means, remember, the data can be fragmented, right? Some data is in site A, some data is in site B at logical level. But when you write your queries, if you don't need to worry about those, whether data is coming from site A or site B or site C, you don't need to worry about whether it's vertically fragmented, horizontally fragmented, mixed fragmented. For you, it is just a normal query. It's the distributed database management system's task to identify those fragments and get those data from different sites. So that means you have the fragmentation transparency. Right. So now we are into different classification. Right. So that is design transparency versus execution transparency. So design transparency means when you design, when you write your queries and so on, you don't need to worry about that. Okay. Because it's handled by your database. So execution transparency means it's more related to the database itself. Okay. Database itself. So it hides the implementation or execution level things. Especially this is related when you are doing transaction handling and so on. So these are again very small difference, okay, between design transparency and execution transparency. So execution transparency is more related to queries. Right? So I think that should be highlighted. It's more related to queries because execution, you execute SQL queries, okay, or transactions, queries or transactions, because those are the runtime things. Design level is you design your uh, tables and so on, okay, relationships and so on. That is tables, relationships, not the queries and transactions, okay. Right, so our next subtopic is, this is where you get exam calculation questions, query processing and optimization. Query processing and optimization. Right, now we are into the query processing and optimization. So this is the most critical part because so far it's theory. Theory somehow you can understand, but this is where you get calculation questions. So calculation questions are to challenge you and check whether you have really understand it and also do you have the problem solving mindset. Okay. Right. So remember when you write a SQL query, right? So in normal database, the entire query is executed in one database, one machine, one server. And you know that executing a query involves so many factors, right? Maybe it has a join, two tables, three tables, and your data must be right. So your tables are in files. So you need to read that file, other file, then do a join in the memory. And things become even more complicated when it is a distributed databases because some tables, maybe one table inside one, another table inside two. Okay, so maybe the same data is fragmented, some data inside one, some data inside two, some columns inside one, some columns inside two. Some data can be replicated. Right? So then should I take it from site one or site two? All these complications are there for the database management system to handle. Of course, we don't handle it. But you need to understand theory behind that, how the DBMS handle it. Right? So it doesn't mean that we need to worry about. That is why we have the transparency, right? Location transparency, fragmentation transparency, right? But we must understand the theory, how the database do it. So this is how the database do it. Okay. So we can identify it as four stages, four steps, sub-steps. Query mapping, localization, global query optimization, and local query optimization. So the first one is query mapping. So that means when you write your query, right, you refer it to the global schema. Right? So remember, we refer to the global schema unless you are writing a local query under federated autonomous systems, right? So typically we talk about global queries. So that global query must be translated into more physical level. Like remember your select statement, select blah 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 from this table, inner join that and blah blah blah. That is SQL, right? So that is then translated into relational algebraic query with sigma pi notation. So we discussed that in semester 2, right? Relational algebra. So that relational algebraic expression is then executed at physical level. So first it will check for the syntax errors because your SQL statement may have syntactical errors. And then it will be converted to a relational algebraic query. So that is query mapping and it refers to the global schema. Okay. So this must be done in one particular site. So in one particular site, your SQL query must be executed, right? Mapped. Maybe it is your local site or maybe it is executed in a different site, depending on the way it has been configured. And so that is called query mapping. So the next one is localization. Now your global query must be executed, or sometimes it must be executed in multiple sites. Some data in site A, some data in site B. Right? So that is called localization. So you break it into separate queries to be executed in different sites if required. So the fragmentation, replication details need to be considered. Right? So that breaking out of your query can also be done in the same site where you converted it into relational expression. Because still we have not start executing, right? We are just in the process. Okay, so that is localization. So then you need to do the optimization because we want to uh, run the optimum query for performance, right? Optimum query. So the first one is you can do the global query optimization. That means now remember that now we have break it into subqueries and so on, right? Now you want to find out what is the best way to do that, because some data is in here, some data is there. And should I take this data from here to here, and then execute it? Or should I take this data to this side and then do the join and then take the data? Or should the DBMS take this data to this side, do the join, and this take the data? So many possibilities. If it is three tables, maybe more complicated, more possibilities. So at least you can see that. So this is, I'm referring to the global query optimization. If your query involved two sites and your query is executed in C, site A, site B, at least there are three possibilities. Say you are executing it here and you want to set the result here. Assume your query is executed in your site. So at least there are three possibilities. What is the first possibility? You say one table is here, other table is here, and you need to combine data. So one possibility is you take data from here, and do the join here and send the data. So that is possibility number one. So this is global query optimization possibility number one. Possibility number two, you take data from here to here, do the join, and take it here. So that is another possibility. Right? So there's a third possibility. You take this data to this side and do the join here and take the data. You can see at least three possibilities. But when you have three tables, four tables, more possibilities. So global query optimization means you need to identify which approach is the best. Is it the first approach, second approach, or the third approach? Because sometimes there's a big difference in performance. Big difference. Okay. That is identifying what is the best approach is called global query optimization. So these things must be done in split of a second, because you can't spend a hell a lot of time to do the optimization, because then you need to execute that also, right? So that is where you need statistical data. Remember the database has data part, metadata or data uh, dictionary. So your metadata or the data dictionary has for the table names, column names, and blah blah blah. Yes, those are there. At the same time, it keeps these statistical data. For each table, how many records are there, right? How it has been fragmented, especially if it is distributed database management system. And also it has some basic data about last executed queries. How many milliseconds it took for executing a particular select statement for a particular table in a particular site. Right? So it consider all these things and decide which approach is the best. Is it this approach, or this approach? Because it needs to identify the best approach and then immediately execute it. So that is called global query optimization. And this is where you get second paper question most of the time. So they give you a statistical details, not statistical, actually the file size and so on. And they will ask, uh, most of the time you get this kind of scenario, three table scenario, and they will ask, consider these three approaches and identify what is the best approach. What is the best approach? Right? So this is very important. This is where most of the time you get a challenging second paper question. Global query optimization. Okay. So then we have the local query optimization. Now, once you decide the global query, right? For example, you take data from here to this side, then do the join and take that. So then here there must be query executed, right? You take that data from here. So that also we can optimize. Maybe you have indexes and so on. Here the join we can optimize because here also you need to read data. Right? So that means your local optimization. So that is optimization done. That means you want to execute the optimum query in individual sites. Now this is based on your global query, right? Now you have decided how it is going to be done, but individually you need to execute SQLs in these sites now. And those SQLs also we can optimize, especially using indexes. That is called local query optimization. Okay. So that improve our performance. Okay. And I forget to mention one thing, when we do the global query optimization, it is not just the time taken to access data. The biggest overhead is transferring data from one side to the other side because you need to take it through network. Yes, accessing file is very costly, but sending data to network is even higher cost. Even higher cost. So you need to consider all file access and transmission time, transport time. You can see you can get very challenging questions. Right? So this is, as I told you, for the global query optimization, these are some possibilities. Actually, this should come under global query optimization. Say, this is where you want the result. You take data from here, and consolidate and send it. Right? Or you take data from site B to A, and then consolidate, join, and take to the site C and give it. Or you take site A data to site B and do some joins and take to the site C and give it to the outs application. So these are the three possibilities in global query optimization. Okay. Right. So shall we put it into global query optimization? Otherwise, you will get. Right. So this is basically under. Sorry, not this one. Right. So this is under global query optimization. Okay. Right. So this is an example. So pay a lot of attention to this one because there are past paper questions pretty much similar to this. This is directed from your UCSC slides. Okay. So read the question very carefully. Almost every year there's a question like this. Suppose employee table and department tables are stored in node 1 and node 2 respectively. So node 1 has the employee table, node 2 has the department table. Right? And they have given you additional information. Number of records, 10,000. That means employee table has 10,000 records. And each record is, one record is 100 bytes. Department table, there are 100 records, that means 100 departments, and each record is 35 bytes. Okay. Results are expected to be presented in node 3. So that means after executing a particular query, the results must be given to the site 3. So results are taken from site 3. And there must be network connection between these. Right. Now the question is, the sizes of and also they have given you some sizes of the attributes. Okay, some attributes, not all the attributes, the essential one for the calculations. For example, employee table, the first name is 15 byte, last name 15 byte, address 10 byte, department number 4 byte. So basically, SSN is the primary key, department number is a foreign key. Okay, and department table. So these three fields, field size is given, and obvious department number is a primary key. Okay, this is manager SSN, manager start date, maybe recursive relationship. Right? So this is the minimum required they have given. Okay. And also they have given, okay, so these are given F name 15 bytes, L name 15 bytes and 10 bytes, and department number 4 byte, department name 10 byte, and manager SSN is 9 byte. Okay. Right. Now the question. And they have already given now how many records are there and what is the total size. So that is total size. Okay. Total size means if you take entire record. Okay. Adding these fields values also. Right. So this is a question. Assume we want to write a query to retrieve first name, last name, and department of each employee. So let's assume department means department name. Okay. First name, last name, and shall we call it department name? Otherwise, for department details. Yeah, first name, last name, and department name. Okay, so let's call it department name. So that is more clear for you. Right, so at the end, we need these three data. Okay, first name, last name, department name or D name. Okay, department name for each employee. So you need all the employee details, all the employees, right? Not just some employees. Right. So now you need to consider what is the cost, what is the time required to perform this. Okay. For different strategies. What are the three strategies now we have? Because we have three sites. Take data from here to here, take data from here to here, do the join here, and give the data. That is strategy one. Okay, let's take that first. Okay. And usually this is the highly costly strategy, the worst strategy. But anyway, let's take that first because that is the easiest. Right. So this is the relational algebraic expression. So you need to join employee and department table in a join using department number. Why do you want to join employee and department table? Because department name is in the department table. Employee table has only department number. Remember our query, we need department name. So therefore, we need to do the join. And then you need the first name and last name from the employee table and department name from the department table for all the employees. If they have 1,000 employees, we will get 1,000 reports. Right? At any time, if you feel like you have lost it, let me know. Okay. I can, because don't tell me at the end I have not understood this, right? No, I'm not going to repeat this. But the moment you find it, you have lost it, just tell me. I will explain it again, that particular part. Right. So this is our first solution or the basis for solution. So remember, our site one has, node one has 10,000 records, 100 byte each. Okay. So that means what is the total number of bytes? 10,000 into 100 byte. One record is 1 byte, sorry, 100 byte. We have 10,000 records. Okay. So that is total of 1 million byte. 1 million byte. Because we are going to take that data to the site C, site 3. What about the second site? Site node 2. We have 35 byte into 100. Each record is 35 and we have 100. That is 35 into 100 bytes. That is 3,500 byte. Okay, so now the idea is you take the data from employee tables to the site 3, node 3, and take all the data from department table to node 3. Now, what is the total number of byte transferred? So that is you need to transfer this 1 million byte from node A to node 3, and this the 3500 byte from node 2 to node 3, because the join is going to be done in node 3. So therefore, total number of byte transferred is 100 into 10,000 plus 35 into 100. So that is this and this. That is 1,003,500 bytes. Now this 3,500 byte must be transferred from node 1 and 2 to node 3. And then in the node 3, we can do the join. And then you get rid of all the unnecessary fields, because we have transferred all the records, all the fields, because we just need employee first name, last name, and department name. And then you just extract those in the memory and give it to the application. Anyway, that happens in node 3. And we need the result in node 3. So therefore, there's no more further data transmission. Remember, the biggest cost is data transmission. So considering the data transmission cost, disk access cost is negligible. Disk access cost is negligible considering the data transmission cost. That is the idea. Right? That is the idea. Okay, got it? So therefore, what is the cost for this transaction or this query? If you do like this, 1,003,500 bytes. Okay. So that is our method 1. But here we did not consider any optimization. So can you think of possible optimization here to reduce this number of bytes? Assume that we are going to do like this. We are not going to change the strategy. That is site 1, site 2, you take to site 3 and give the results. Assume that this is our strategy. Within that strategy, can we propose a way to optimize or reduce number of bytes?
Using projectivity.
You need to explain. You need to explain practically how we are going to do this.
In SQL statement, we can read out unnecessary fields.
Yes, that's it. For example, we took all the records, all the fields. Of course, we need to take all the records. We have no other option. But remember, we just need employee, right? First name and last name. Okay. But we have so many other fields, right? Salary, sex, address, birth date. Why do you need this? So what is the minimum you need to get from site 1 to site 3? Anyone? What are the minimum? So remember, this is our final query. First name, last name, department name from employee inner join department based on department number. Now, can someone tell me what is the minimum? What are the minimum? What are the fields you need to take it from site 1 to site 3? So you need a first name, L name, department name. That's it. At the end, we need only these 3. Yes, first name, last name, department name. My question is, what are the minimum number of fields we need to, what are the minimum number of fields we need to take it from site 1 to site 3? So obviously we need to take first name, right? Because that is part of our result. We need to take last name. And again, we need to take one more. What is that? One more field you need to take from 1.
Department ID.
Yeah, department number, because join is done here. So in order to do the join, you need department number. So therefore, though it is not part of your final result, you need to take department numbers because then only we can do the join. And from department table, you just need to take only department number and department name. That's enough. And then do the join and give the result. So then this will be reduced. This will be reduced because it's not 100 byte, then less than 100 byte. Okay. So that means basically here it will be 15, 15 and 4. That is 34 bytes. So 34 byte is way lesser than 100 bytes. And here you just need to take 10 and 4, 14 byte. Okay. So here it will be 14 byte. But in the exams, usually for method 1, they don't do any optimization. So they just expect no optimization solution. Okay. So therefore, don't do that kind of optimization when you're taking from the two sides and do the join in the third side, because in the exam questions also they have not done that optimization. So basically they want the worst case. Worst case. Okay. Right. So just assume that you take all the fields, all the records, all the fields and do the join. And this is considered as a worst scenario. Right. No optimization. Okay. Right. Because we need to comply with the examiner's expectation, right? Or maybe you can write a note saying this is no optimization solution. Further optimization can be done by only selecting relevant fields from site 1 and site 2. Because we need to go by your marking schemes, right? All past paper marking schemes, because they in past paper answers, no such optimization is expected. For method 1, okay, because this is sort of a no optimized solution. Right. So now let's see another possibility. So second possibility, because we have 3 possibilities. Yeah. So this is my node 3, node 1, node 2. Node 1 has employee, node 2 has department. So this solution is you transfer all the employee details to the department node and do the join here and then take it. Okay. Okay. Right. So now again, now we are going to take all the records from employee table to this side. So how many records are there in employee table? 10,000. Okay, 10,000. How many bytes for each record? 100 bytes. So that means 10,000 into 100 byte is transferred from 1 to 2. Right? 10,000 into 100 byte is 1 million byte. Again, don't do any optimization. Okay. And don't think that we are going to take only the required fields. No, we are going to take everything. So that means we have 1 million bytes transferred from 1 to 2. Now you can do the join. Join here. Right. Now what we are going to have after doing the join. Again, remember if we got 10,000 employees, from here to here also we are going to get 10,000 employees because we just need to find the department name for each employee. That we can do here. Right? That we can do here. Okay. So we have 10,000 employees, but now we have the department name also after doing the join. But now we are going to do the optimization and take only relevant field. For example, the first transfer don't optimize for field names, but second transfer optimize for field name because this is the expectation of the examiner. Okay. So now remember, still we have 10,000 records after join, because if you have 10,000 employees, final result also are going to have 10,000 records. But now we are going to, after doing the join, we are going to take only required fields and take it here. So what are the required fields? first name, last name, department name. So what is the size of first name? Because first name and last name is already here. Okay. So the first name is 15 byte, last name is 15 byte. And from department table now we have got the department name 10 byte. So 15, 15, 30, 30 plus 10, 40. So only that 40 byte of record data for each record we can transfer, because now we have done the join also. So therefore we have further 40 byte into 10,000. Why 10,000? Because we have 10,000 employees. But 40 byte because now we have done the projection. So projection is done after joining. And that 40,000, 40 into 10,000 is 400,000. From here to here, 1 million data is transferred because we do not do any optimization there. Optimization is after the query. And here now, after joining, we have 10,000 record, but only 40 byte. So that is 400,000. And this is this transmission, and this transmission is only 400,000 bytes. That is coming from here to here. So therefore, what is the total data transfer? From here to here, 1 million, here to here, 400,000. 1,400,000 bytes. Now earlier, 1,300,500. Actually, this is little bit better than this. This is the worst actually. This is worst because this is 1,400,000. Okay, 1,400,000. Right. So this is the worst actually. I thought the previous one is the worst. This is even worse than the approach one. Okay. But remember that you do the projection optimization only after join. That is the assumption. Right? That is the assumption for your exam questions. Right. Then what about the method 3? So method 3 is you transfer department details to them. That is site 2 to site 1. Right? Site 2 to site 1. That is department details you are taken to the site 1, where you have the employee details. So then you do the join and then transfer the result. But don't you do your optimization only after join. That means you take all the fields from department, but here you take only relevant fields. So therefore, full department details are transferred to this. So that means we have department table 100 records, 35 bytes. So that means 100 into 35. Okay, 100 into 35. 100 into 35 is transferred. That is 3500. 3,500 byte is transferred from here to here. Right. And now you do the join here. So after join, we have obviously 10,000 records because 10,000 employees are there. Okay. But now we have only those 3 fields: first name, last name, department number. So that sum is 40, right? 40. That means 10,000 into 40. 10,000 into 40 is 400,000. So here 400,000 byte. Here 3,500 bytes. And now we have the data here. By the time we got the data here, we have 3,500 plus 400,000 data transfer in the network. We have ignored file handling time because compared to the network transmission time, file handling time is less. So we can ignore it. So this is not time, right? This is byte. Of course, you can assume that each byte take this much of milliseconds or nanoseconds. So therefore, number of bytes is an indication of the time. It's like time is money, right? Time is indication of money. So number of bytes is an indication of the time. So therefore, this is the best solution so far. because it needs only 403,500 bytes. This is not millions, right? So earlier we got millions, right? Method 2, 1 million, 1.4 million bytes. Method 1, 1 million and 3,000. But therefore, this is the best so far because you just need to transfer.
Sir,
Yes.
why we didn't optimize after inner join in employee table
We have
in
optimized.
method 3?
So that is why we have only 40 byte. That is the number of only considering first name, last name, and department name. That is why it's 40 byte. Otherwise, it's 100 byte. Is it correct? Have you got it?
Got it, sir.
Yeah. So we have done the optimization, but we do the optimization only after joining. That is the assumption for your exam questions. Okay. Of course, if you want, you can do the optimization here also, but let's go by the expectation of the examiner. So therefore, this method 3 is the best solution for the out of these three approaches. Okay, out of these three approaches. Right. So in general, the best solution is you look at where do we have the least amount of data, and that data you take to the other side, and then do the query and do the optimization of optimization means take only relevant fields and take it there. So usually that is your best solution. Best solution is take the site where you have the least amount of data to transfer and take it to the other side, and then do the join and also project it only relevant fields and take it, and usually that is the best solution. Second best is usually you take the two sides of the data here and do it. The worst solution is you take the bigger data chunk to the other side where you have the lesser data, and then you take it to the third side. Okay. In general, it can be different, but if you forget about that optimization in the first query, that is only optimized after the join. So usually that is the approach, right? So the best approach is take data from the lesser storage one to the high storage one, do the join and do the projection and take it to your side. Is it clear? Because examiners usually ask about all three. Okay. So we want to multiply by 100 byte. I don't know which one you are referring to. So yes, we multiply by 100 byte, right? I'm not very clear about what the question is. Okay. Right. So you can see that out of these three solutions, the third solution is the best. Okay, optimal. And you can see it's better, about 3 times better than the other solutions. Right? Not 3 times. If you consider this one, it is even closer to 4 times. Okay. Right. Is it clear? Right. So now we can do some past paper questions. Okay. Past paper questions. Basically, we can do 2024 question 1C, D, and E, and 2023 1 ABC. I didn't check the 2022 paper. Just I think you can do even 2022 paper question also. But we'll do only these two today. Right. Right. So we'll do the 2024 question 1C, D, and E. Okay. Ideally, you should do this. That is the best, right? Because me doing, because I already did a example in your UCSC note. And we'll do like that. We'll do these two questions in the evening session so that you have the time to attempt it. Okay. Otherwise, I will take out that opportunity from you guys, right? Definitely now you can do these two questions, and make sure that you somehow do this and check the answers and see whether you have the correct answers. Then your confidence will be sky high, sky high. But okay, otherwise, me doing this is not going to work because you are going to the exam, right? Not me going for the exam, right? But definitely, we are going to do this as the first thing in the evening session. Okay, evening session. Right. So let's yeah. So I give it to you guys. So let's now continue with our discussion on uh, distribution databases related to NoSQL databases. Right. Some special things related to NoSQL, because now so far what we have discussed is related to relational databases. Right. Relational databases. Okay. Right. So when it comes to NoSQL databases, remember NoSQL databases are for more flexibility about the semi-structured, unstructured data. Okay, so therefore, there's a distributed database concept is more relevant to the NoSQL databases because that is where we have a lot of data, right? Like Facebook, social media, right, and that kind of things. Uh, because relational databases are more used in banking applications, right, supermarkets, right, and that kind of things where distribution is little bit risky because these are some critical transactions, right? Critical transactions where the things must be happening in pinpoint accuracy. Sometimes we can compromise a little bit of a performance for reliability and proper transaction handling. But in NoSQL, for example, you know that in Facebook, right? So you write a post, you write a comment, and so on, right? You don't do money transfer, right? You don't care if one of the friends comment to your post, and it might take, maybe you can't see the comment, but your other friends can see the comment on your post because they are connected to a particular node and you are connected to a different node. But that is not a critical issue for you, right? Because that is what we call eventually you need the stability. Immediately you don't expect. It's okay because this is not like a money transfer. But if the balance is not updated, of course there can be fraud. Someone take further money, withdraw money. So therefore in NoSQL, we use this distributed database concept more frequently because those applications also better suited for this kind of usages. Because here we have millions and billions of users using Facebook and so on. Okay, Instagram, where the things are more casual. Okay. Right. So remember, when it comes to NoSQL databases, we are more interested in the scalability. Right? Scalability and reasonable performance. Reasonable performance rather than 100% accuracy and so on. Okay. So there also we can use both horizontal scalability and vertical scalability. So horizontal scalability means you add more and more nodes. More and more nodes. Server level or database level. Vertical scalability means we have already discussed this, right? Improve the performance of or the capacity of a particular node, individual nodes. In this case, storage and so on. Right. So remember in NoSQL databases, what we are interested in is eventual consistency, not the immediate consistency. If it is a banking application, the airline seat reservation, yes, we are interested in immediate consistency. We need that consistency as soon as possible. But here, maybe just a comment, post, right? What we need is eventual consistency. Right? At the end of the day, you must see your friends comment. But if you don't care, right? If there's a small delay, maybe your friend has updated this comment, but still you see the old comment. Maybe after 5 minutes, you see the updated comment. That is usually okay. for that kind of application, right? Because this is not a banking application. So that is what is called eventual consistency, which is good enough, right? At the same time, we need availability, replication, and so on. So because we are more interested in giving them quick responses, what they need is see something fast. Okay? And a lot of replication we can do, duplication. So that now remember, why do we have social media special packages? Right? So you know that 1 GB how it cost in your normal package, but for 400 rupees, 600 rupees, unlimited Facebook, unlimited YouTube. So the reason is lot of replication. Almost all these things are replicated in our servers in SLT dialog. So therefore, no traffic going beyond dialog, beyond SLT. Very little. Say right. So we call it edge computing. Right? In semester 1, we discuss edge computing. So this particular Zoom meeting, Zoom session, right? Almost all of you guys are from Sri Lanka. Maybe just one or two outside. So therefore, the 90% of the data transfers is within our local networks. So that means our dialog SLT, they don't need to pay to the regional ISP providers because it's internally handled. Because internal our internet part is our property, right? So you need to understand how these applications are developed, strategies and hosting strategies. So therefore, in general, NoSQL databases prefer distributed databases. And they are more interested about availability, replication, rather than the 100% accuracy. So what they need is eventual consistency. Just give me 1 minute. Hello. Good morning. Oh. Right, sorry for that. Okay. Right. So therefore, remember, the more replication means more inconsistencies. More inconsistencies, but that is where we use these these databases for this kind of application. So that means your task is come up with the solutions which are relevant to your applications. Right. So where you need a lot of accuracy, go for one, right? Less replication, maybe more relational databases. Where you need more availability, performance, go for distributed databases, NoSQL databases, and so on. Okay. Right. I already explained about what is eventual consistency is. Right. So maybe immediately you don't see the reality, but at the end, maybe after a few seconds, you see the reality, which is good enough for this kind of non-critical applications like social media. Okay. Right. So in NoSQL databases, again, we use the same thing. Okay. But we use slightly different words. Right? Remember, earlier we used master slave and peer-to-peer. But in NoSQL databases, we use slightly different name, that is master slave and master master. Okay, master slave and master master. Why there's a difference? Because we have two different type of applications. So this is more optimized for this non-critical, right, applications like social media. Right. What is mean by master slave? So that is same as in normal database, normal app discussion we did. So master is responsible for the write operations. Okay. And the master propagated to the slave. And slave is more for the reading. Right? So master is your mainly for writing, and you have many slaves, and most of the reads are done through the slaves. So that is same as what we have discussed so far. Right? So therefore, the same approach we can use in NoSQL databases. Okay. And again, of course, there can be small delay because all the updates are done to the master. It must be propagated. That delay, most of the time, you can tolerate. You can tolerate. Okay. So that is master slave replication. So the next one is called master-master replication. Okay. So that means all nodes are treated similarly. So that means for any node, you can do write, you can do read. So this is just a different name for peer-to-peer. Right. So in normal databases, we call it peer-to-peer. In NoSQL databases, we just call it master-master. Right. So again, there can be inconsistencies because when you write somewhere here, maybe you can see that your change, but maybe others changes. When they do some update here, it will take some time for you to come here. But okay. So that means this is pretty much like, or pretty much peer-to-peer. So therefore, the same advantages, disadvantages are there. Okay. Advantages, disadvantages are there. But most of the time in NoSQL databases, master-master is good enough because usually what you want is what you write, you want to see, right? What you edit, you want to see it immediately. But other things you can always, right? You can wait for little bit of a time for eventual consistency. Okay. And you don't want to have performance bottleneck of just having one master for write, right? Because we have millions and billions of users. So therefore, most of the time for that kind of a social media and so on, master is the better approach. Right. So then shredding of the files, right? So that is physically how you allocate. Again, it's a big issue or big challenge here because we have a lot of contents created, a lot of users using. Okay. So again, you can go for whatever the relevant approach when it comes to allocating resources and so on. Okay. Basically, the idea is to balance the performance or the overall performance must be the best. Okay. Right. So when it comes to optimization, so there are some techniques used. So basically, I'm mostly referring to social media like things because that is where we use NoSQL databases. So the idea is mostly whatever you write, you want to see first. Or because most of the time you are getting notifications about your post, your comments. So there's a like for your post and that kind of things. Okay, so that is the reality. So therefore, we try to make sure that a particular user is always connected to the same node because otherwise you write it here and now you are connected here. So the idea is you always connected to your site. Another user is always connected to that site and so on. So that most of the time you get the immediate picture. Okay. So how do you make sure that you are always connected to the one site? Using concept like hashing, range partitioning, and so on. So remember, say your hash is related to your use ID. So then you get the same hash and that hash will determine which site you are connected to. So always your use ID will give you the same hash. So that means you're always connected to the same thing or depending on some logic, right? Maybe depending on your location, IP address location, right? So your application will decide to which site you are connected. Okay. So that is just to make sure that the users are getting better experience. Okay. Right. So the two past papers we will discuss uh, after the in the evening session. Okay, today evening session. Okay. Right. So now we'll take another break. After the break, we'll move on to uh, data structures and algorithm, and we want to finish our discussion on trees. Okay. Now we have almost done it, but we want to finish it. Okay. Right, so now it's 10, say 10:20. We start at 10:40. And then we'll finish our discussion on trees. Okay. Okay, so now let's move on to data structures and algorithms. So last time we start tree data structure. So we discussed some terminology. Okay. And what is a tree data structure? Right? You can have multiple children, but node can have maximum one parent. Okay. We look at some terminology like what is root node. You can have only one root node for a tree. Then edge, parent nodes, child nodes, leaf nodes, internal nodes. If it is not a leaf node, it must be internal node. Okay. Sibling nodes, ancestors. What is degree of a node? How many children are there is your degree. Degree of a tree, the maximum degree of any node is the degree of a tree. The level of a node, right? Height of a node, depth of a node. Remember the difference between depth and height. Depth of a tree, then path, subtree, forest. What is mean by visiting? What is mean by traversing? And of course, we discuss about some traversing techniques. Then we subdivided trees into binary trees and general trees. And our discussion is right now in binary trees. So binary tree means the maximum number of nodes is 2. You can't have more than 2 trees. So then we subdivided our discussion into 2 special cases of binary trees. That is binary search tree and binary heap. Okay. And right now we are in the discussion of binary search tree. Okay. And also we look at some special cases of binary trees like full binary tree, perfect binary tree, complete binary tree, pathological tree, skewed binary tree. So then we moved on to binary search tree. So binary search tree is a binary tree where for each node, the nodes left of it must be smaller than that node. The node right of the node, that node or the nodes must be bigger than or has a higher value. So that must be true for each and every node. So then it's a binary search tree. Or in other words, in simple terms, it's sorted from left to right. So we discuss how to build a binary search tree when given data is given. So first, when you insert a set sequence of data, everyone must get the same binary search tree, right? There's nothing called different binary search trees because there's a very precise logic. So then we discuss how to implement it. The node class is pretty much like the node class for linked list, but we have 2 instance variables, recursive relationships. We call it left child and right child, and we keep track of the root node. So then we start implementing methods, right? We implemented the insert, right? Find min, find max. Okay, so those things we implemented in the last class. Okay. And also we implemented the pre-order traversing. The pre-order traversing. So let's see which one we have implemented. Right, so we implemented the node class, and then we start implementing the binary search tree. We just keep track of the root, okay, root, and then we implemented the insert method. Remember, you need to go to the correct node, and then you add it as a left child or right child, depending on the value. So then we implemented the search method, which is very easy. You start from root and keep going, keep going, keep going until you find it. Or you exhaust. Exhaust means that element is not in your binary search tree. Okay. So find min and find max, I gave it for you as exercise. Okay. Because it's very easy. So shall we implement it? Because you have 1 week to do that. Now you should have used that opportunity for solving. If you are interested in solving problems, you should have done it by yourself, right? That is attitude issue, right? If you don't have that kind of attitude, don't do IT, right? Find something that you like, right? So let's do this because this is very easy. So let's say node, say or current equal root, because we keep track of the root. So then we need to keep going for left, 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 because your leftmost node is the minimum node. While your curry is not null, your current node is not null, you keep moving leftwards. Okay, so car equal car dot left, right? Left child, right? Left child, that is what we use. And when your current become null, of course, then it is too late, right? So remember, if current is null, it is too late. So that means we need to come to a situation where you keep coming like this. Right, you keep coming left, coming left, coming left. Of course, if current is null, we have already passed that node. So therefore, if current dot left is null, you need to stop. When current dot left is null, you are in the leftmost node. Right now, current is null, current dot left is null. Okay. Right. So current dot next is, sorry, current dot left child is null. You get out of the loop. That means you are in the leftmost node. Okay, leftmost node. But there's a possibility of null point exception here. If your tree is empty, right? If your tree is empty, you will get a null point exception, right? We don't want to get into null point exception, right? That is bad. So therefore, if it is empty, we will give error message. Okay, we will give error message and return if car equal null, because that's a special case. We will give error message yes out, empty tree is empty, so therefore you can't find min. Okay, and we can break, because otherwise you will get into this kind of a, okay, because then left child will be null point exception, right? So therefore better we return. And if not, say return -1 or whatever. So let's assume -1 means invalid or it's not, it's empty, okay? Right. So then here, when we are exhausted, that means current dot left child is null, we get out of the loop. So then your current is the minimum node. So we can return cur dot left child. That's it. So why there's error? Like left child, it's data. Sorry, car dot data, right? Not car dot left child, car dot data. Right? Because there's no left child means you are the leftmost node in your tree. Right. So let's test this. I have already implemented one more method that I will explain. Okay. So therefore, don't worry, because that is I did a small change to this slide also. If you have already downloaded the trees node last week, I think about 2 days ago, I uploaded again. No, today I uploaded again. So make sure you download it again, okay? Because I added breakfast. Because the last time I told you we are not going to do the breakfast searching code, just the logic, but I just added that code also, okay? Because using Q we can do it very easily, right? So now let's test this one. Find mean. And so this is breakfast traversing, which I will not execute because I will explain it later. Now let's do, before traversing, let's do this one, okay? We will just write it in S out. BST is our tree. Find min, right? So we should get 20, right? So 20 is the smallest, right? So far, okay, 20. So the results must be 20, 20, okay? Let's say min is so that we can see it. Let's run it. So if my logic is correct, I should get no null point exception, nothing but 20. I hope you implemented that, okay? Right, min is 20, correct? So now, of course, you can implement the max also, because same logic, right? You can copy paste. You can copy paste. Right. Only difference is, right? Only difference is you are going to the right child. Okay. You are going towards right. Okay, that's it. Right. So let's test the find max also. And if things going well, I should get 100, right? Yes, 100 is the biggest. Sorry, 80. This is search, right? So this is search. So therefore, yes, maximum is what? Because this is search. Maximum is 80. This is our insert. Okay. The maximum is 8, correct. Okay. Right. So then last time we implemented, right? Remember there are 3 type of depth first searching. So depth first means we try to go into depth. And I implemented one of those, and I asked you to implement the other two and test it. Okay. So what we implemented is pre-order traversing. So pre-order traversing means current, left, right. Only current is print. Right. So then you recursively do it for left and right. Okay. And I asked you to implement the understand yourself the in node and post node and implement it. Okay. So when I give it to you, make sure you do it, right? Otherwise, you will never get into that kind of a mindset of a software developer. Okay. Right. So let's recreate this binary search tree at 55, 80. Right. So let's recreate this. At 55, that is our root. 80, okay, let's not 70, 30, 40. So you know how to add it, right? 70, bigger than 55 but lesser than 80. 20, 45 and 70. Bigger than 30, bigger than 40. And 70, bigger than 55. This 70 is not added because 70 is already there, right? So remember we implemented that also. If the same value is there, we ignore it, okay? Yeah, so we just say false. Right. So then what was the result when we do in pre-order traversing? Right. We implement the pre-order traversing. Right. Pre-order traversing we implemented PROT, current, left, right. So what was the result? Just refreshing. Current, only current. When we say current only, we print it, okay? Current. So then recursively do it for left, current. Do it for left, current. Left, right. Now we are done. Here current left is done, right. Current. Left nothing. So then right, current. Nothing's left, right. So here fully finished, fully finished, fully finished because current left, right is done. Here we came current and left. Now we are going to right. Current. So then left, you say current. Left, right, this is done. So here current left is done, right nothing, right nothing, right is also done, not everything is done. The result is 55, 30, 20, 40, 45, 80, 70. Okay, so we implemented that anyway. So let's run it. Let's see whether the answer is correct in our case. 55, 30, 20, 40, 45, 80, 70, correct, right? So that is something we did last class. And I asked you to understand yourself what is in-order traversing and implementing. Okay. So in-order traversing is left, current, right. Left, current, right. Okay. So therefore the implementation is similar to this, but slight different order. It is left, current. First you are recursively calling it for left. Then current, and then right. Okay, so that is called in-order traversing. So let's see what is the output before running by our own intelligence. So this is pre-order traversing, right? Pre-order traversing. So now what we need is in-order traversing. That is what left, current, right. When you say current only, you print. Okay, right. Left. Again, left. Left, nothing. Current. When you say current, you print. Right.
Sir,
Sorry?
pre-order traversing means current left, right?
Yes.
And in-order traversing means left current, right?
Right. Okay, left current right.
Ah,
So this is
okay.
my left. This is my current. This is my right. So when we say current only, you print it because left and right are recursions. Okay. Right. So therefore, again we'll do it. So this is starting point is always root. Now we say left, right? That means again recursively left. Again recursively left, nothing. So current. So therefore I print it. Right, nothing. For this one I have come left. Now it is current. And right, again recursion. Left current, print it. Right, so then left current. Right, nothing. So this one done, this one done, this one done. Remember, from here we came left. Now only current. Right, again recursion left. Again recursion left, current. Nothing in right. Now here left we have come, then the current. Nothing in the right. And therefore we are done. So the result is 20, 30, 40, 45, 55, 78. And always, if it is a binary search tree, when you do in-order traversing, it will be sorted. So that is basically, if you want to sort your data, you put it into the binary tree and do the in-order traversing, right? So if you want to preserve your time, if you know that it's a binary search tree, in-order traversing always give you the sorted data because that is the whole purpose of binary search tree. Anyway, let's run and see our answer is correct. Right, so now we can check IoT, right, in-order traversing. So where is that in-order traversing? INOT. INOT. I have called the pre-order traversing, so I should call what? In-order traversing, right? So my recursion is wrong.
So can you explain how you got in-order traversing again?
Okay, I'll explain, right? Right,
Okay.
so now the recursion is in-order traversing. Right, so let's run it now. Because earlier I had made a mistake calling the wrong recursion. Right, so this is my in-order traversing. So I should have a println here, right? S out, so that it goes to the correct one. Otherwise, it will print in the wrong line. Right, so this is my in-order traversing, and you can see it's correct. 20, 30, 40, 45, 55, 70, 80. 20, 40, 20, 30, 40, 45, 55, 70, 80. Basically, it's in sorted order. Okay. So I'll again explain how the in-order traversing is done. So the idea is left, current, right. Remember, left and right are recursive calls. So therefore, we always start with root and then say left is a recursive call. Again, say left, recursive call, left, current, okay, right, nothing to recursively call. So then from here, we have come to the left. Now it is current, okay. So then right means recursive call, left, current, right, it's a recursive call, left, current, right. And for this one, we have done left, right, current, left, current, right. For this one, we have done left, current, right. For this one, we have done left. Now we are into the current. Okay. So then right is a recursive call. Left is a recursive call. Left, current, right. For this one, we have done the left. Now current and right. So that means we are done. We come back to the root node. right? So left or right is recursive calls. You need to
Means
keep track of
we
the
should come
recursion.
from bottom.
Okay. Any questions?
So in order traversing, we should come from the bottom part.
What do you mean by come from the bottom part? No, we always start with the root. You just follow the logic. Don't think about anything else, right? Just follow the logic. Always, whether it's in order, pre-order, whatever, we start with root, right? So what is the logic?
Okay.
Left, current, right. Current only you are printing. So therefore you go left, it's a recursion. So therefore you go left, it's a recursion. Left, nothing. So that means recursion ends for that branch. So then current, now you print it. Right, nothing. So from here you came left. Now current, left, sorry, right, recursion, left current, right recursion, left current, right, nothing. So here we have gone left current, right. Here we have done left current, right. So that here we came left, now we are into current. So then right recursion, left current, right. Here we came left current, nothing to go right. Here we have finished. Now everything is finished. So don't think any shortcuts, nothing. Just concentrate on the logic recursively. Okay. So this is the output. This is the output. Okay. So now we have covered pre-order traversing. That is left, right. Sorry, current, left, right. Then we have done the in-order traversing, left, current, right. So third one is post-order traversing. POT again, but post. Okay. So post-order traversing means first you go to left and right. That is why we say post, left, right, current. Pre-order means current, left, right. In-order means left, current, right. Post-order means left, right, current. You come to the current after. That is why we say post. Right? Left, right, current. Left, right are recursive calls. Current is printing your value. Okay. So therefore the implementation is, okay, so let's go through it first. Now you need to do how? Left, right, current. Okay. Start from here. Left, recursion. Left, recursion. Left, right, nothing. So then current. Current. So then here we came left. Now right. Again recursion. Left, right, recursion. Left, right, current. Right. So now for this one we have done left, right, current. For this one we have done left, right, current. For this one we have done left. Now we are going to the right. Okay. Even now it is left, right, current. Okay. Left, right, current. Current is the one that you print. The logic is left, right, current. Current is one you print. Okay. So now where are we? For this one, we are in the left we have done. Now we are going to the right. Okay. So then recursion, left, right, current. For this one, we have gone left. Now we are going to right, nothing. So they are into the current. Now for this one, we have done left and right, current. So this is the output. 20, 45, 40, 30, okay. 70, 80, and 50. And there's a small, nice pattern here, okay. I prefer you to find out the pattern. You can see if you look at this, there's a nice pattern. This is your first one. Then this one, then this one. So then this one. So then this one and this one. Can you explain it in simple English, but a possible way of understanding this logic? possible way of explaining this logic. There's a little bit of a logic here. Remember, the in-order traversing is you go from left to right. 20, 30, 40, 45, 55, 70, 80. Likewise, you can explain post-order traversing. But of course, if you look at it in over and over and over, maybe 10 minutes, 15 minutes, you might see a little bit of a pattern, and maybe you can find a little bit of analogy. Analogy means similar situation, similar practical situation in day-to-day life. Anyone want to give it a try? Because I gave you enough time to play with in-order, post-order, pre-order traversing. Have anyone seen a bit of a analogy? Analogy can සාමාන්‍ය ජීවිතේ. Sorry?
From leaf to root.
From leaf to root.
Root.
Yeah, it's going from leaf to root, but there's a pattern also. Leaf to root, left to right. Right. So because then we start with here, not here, right? That means you are going to the leaf. Okay, so let me. Right. It's something like this. So you are going to the left leaf, right? You are going to the left leaf. Okay, leftmost leaf. So then you are coming back. Okay. So then you are going to the rightmost leaf. You can see that is how the 45. So then you are coming back. Okay. Then you are coming back. Now this branch is over. Right? This branch is over. But you don't come to this one. Now, if left branches are over, now we are going to the right side. Right? So that is how now 30 is already done. Now we are going to the leaf in the right branch, and you are coming back. Coming back. Okay. And if there is something here after 70, it must be this one. Then only this one. කියන්නේ අතු ටික කපලා තමයි කඳ කපන්නේ. ඊට පස්සේ එයා එතනින් ආයි කඳ පැත්තට එනවා. ගහේ කෙරෝලේ ඉඳලා මුල පැත්තට එන්නේ දැන්. හැබැයි වම් පැත්තට ගිහිල්ලා ඒ පැත්ත කපාගෙන තමයි දකුණු පැත්තට එන්නේ. කියන්නේ ගහේ පොඩි පොඩි අතු ටික ඔක්කොම කපාගෙන ගිහිල්ලා අන්තිමට පොඩි පොඩි අතු ගොඩක් ඉතුරු වෙනවා. අර ගහ කපාදු කරනවා. හැබැයි අන්තිමට මුළු ගහම ඉවරයි කපාදු ඉවරෙද්දි. හරි ටික ටික කපාදු කරලා මුළු ගහම කපාදු වෙනවා. Okay. Right, so that is how we go through the undo everything, right now it's okay. So let me delete this. That is in order traversing, because in MCQ sometimes they give you the tree and ask what is the output when you do the in order traversing output, because some students they can't handle this. Right? Some students can't handle this. So examiners want to check whether you can handle this recursive thinking. Forget about programming. Okay, right. So those are what are the three traversing we discussed? Pre-order traversing, in-order traversing, post-order traversing. All three are depth-first traversing because we try to go into depth. Right? Try to go into depth. Okay, so let's implement the post-order traversing as well. Post-order traversing. Post-order traverse. So I'll copy paste this. So this is my post-order traversing. And make sure you recursively call yourself, right? But this time post-order means left, right, and then current. Right? And the output must be uh, 20, 45, 40, 30, 70, 80, and 55. Okay. 20, 45, 40, 30, 70, 80, 55 for post-order traversing. You can say 20, 45, 40, 30, then 70, 80, 55. Correct. Correct. Okay. Right. So those are all breadth first traversing techniques. Sorry, depth first, because we try to go into depth as quickly as possible. Though we start with root, in all three, we try to go to the depth. Okay, in three different logics. So the next traversing technique is called breadth first traversing. Breadth first traversing. So we have discussed this. Right. Sometimes we call it level order traversing. Level order traversing. So the idea is the breadth means you try to stay near root. When the near root nodes are visited, then you go to the next level. Okay. Next level. So it's something like, say we have a cow. Say we have a cow and its child. So this calf or whatever is try to stay near to the mother, right? In grazing or whatever. So when nothing to eat here, only the calf try to go a little bit beyond that. Always try to stay near the mother. Okay. That is how the breadth first traversing happens. So you always try to stay near to the root. If nothing to traverse, only you go to a little bit longer, right? To the depth. Okay. And again, you first go to left and right when you are in the equal level, right? So it's breadth, but first we go left and then right. If there's a left something, you visit that and then visit your right one in the same level. If that level is over, then we go to the next level again from left to right. Okay. So that is called breadth first traversing. Okay, breadth first traverse. So this is an example. So you always start with your root. So this is a very easy one. Right? So you don't need to think recursively for this one. So then 20, 80, that level is over. Then to the next level, 10, 30, 50, 90. So then next level, again you're going from left to right, 25, 40, 85, 95. And then the last level, we have only one element, that is 35. So that is called breadth first or level order traversing. We finish one level and go to next level. In a level, we go from left to right. Okay. So how do you implement this? At first, you may find it very difficult thing to do, right? Because you need to keep track of a hell a lot of things here, right? 45, 20, 80, 10, 30, 50, 90, 25, 40. Now these are in different places, right? How can I implement it? Right? So that is why I asked you to give it a try also, right? So how do you implement this? We can implement this using with the help of what? Can you give me hint? What can be used as a auxiliary support to implement this logic? Because as software engineer, your task is solving problem. So these are opportunities for you to solve problems. So remember, first always we visit the first one because that is the closest to you. Closest to you is you. So then you visit your left child, immediate left child. Then your right child if available. So then your left child, your left child, right child, your other right child, left child, and so on. Now, how do you do that? Here you have more and more nodes now, right? More and more nodes because you have got stuff supposed to traverse like this. So you can use a queue to help keep track of, because if you first visit this and then this, when you are exhausted at this level, then you need to take the first one you visit at that level and then visit. Remember, first in, first out is queue. Now, your first one is this, next one is this, then next one is this, next one is this. So then again, you must try this guy is left child, this guy is left child, this guy is left child if available. And every time you visit, you put it into the queue so that next level you start in the same order. Same order. It looks very complicated logic, but once you use a queue, actually it's a very simple logic. So that is why you learn about these data structures, because data structures can help you solving problems. Some complicated problems you can solve very easily. And with the help of queue, you can implement this very easily. Actually, if you spend about 1 hour, right, you may implement it by yourself. Okay. So I have given you the implementation. You can use the queue implementation we have developed under queue, but just to make it simple, I have used the Java queue, right? Java queue. So this is how you do it, right? FDJ BEGK ACIH. Okay. So how do you do that? So this is your first one. When you visit somewhere, you put it into the queue. Okay. When you visit, you put it into the queue. So then you visit that node's left child and put it into the queue. And sorry, once you visit it, right? So then you take it out. So that I forget to mention, right? You put it, visit it, take it out. Okay. So then you visit the left child. Remember, you have already taken this out. Then you visit the right child. Okay. Right? Nothing else to visit. Now again from the queue, you take it out. Now you can see D is take it out. And from there you visit B and E. B and E. Okay. So let me explain it again. So this is my first visit. It's in the queue, and now we have visited. It's in the output also. Okay. Now you take it out. And then visit the left child. It's in the output and it's in the queue now. And then you visit your right child, put it into output, and it is in the queue now. Okay, so you're adding to this. This is your rear. Okay, rear. Right now, nothing to add because only two children are there. Okay, now this is done, this is done, this is done. Now nothing to add. So therefore, now again you take it from the queue. When you take it from the queue, D is out. Take it from the queue and you visit its left and right. So then you print it. At the same time, you NQ into the queue. B and E is now NQ. But J is taken out. Right? So now B and E is there. These are there. Now exhausted. Now again you need to take it out. What is the next one to take it out? J. Right? J. So then you visit T and K, but make sure you add it. Right? You add it. So likewise, you visit your left and right. When you visit your NQ, when you are exhausted, we DQ. Okay. So you NQ, DQ, NQ, DQ gradually uh, until your Q is empty. When your Q is empty, you have finished it. Right? You have finished it. So examiner can ask you to give you this kind of a tree, binary tree, and ask you to draw the Q. Or examiner will ask that, okay, assume that you have Q implementation, write a pseudocode, or as using Java Q implementation, write a code, Java code to traverse this. Okay. Right. So this is a code. Here I have used the Java Q. Remember we discussed about collection framework in semester 1 programming. So Q is interface in Java. Right? Q is interface, but the implementation must be linked list. Okay, because Q is not an implementation class, it's an interface. So let me show you. Stack Q වගේ දේවල් එක්ක programmers IT කරන්න හොඳට familiar වෙන්න ඕන. හරි? Stack Q වගේ දේවල් එක්ක. So we discussed this in semester 1. Semester 1 වල ඔයාලට ඇත්ත ටිකක් පරණ note එකක් හැබැයි හරි. මම ඕන අලුත් note එක දෙන්නම් collection framework එකේ. ඒකත් restructure කරලා තියෙන්නේ දැන්. So this is semester 1 programming note, okay? Right, so this is Q. Okay. Q in under Java collections. It's a first in, first out. Okay. So remember Q is the interface. So the implementation must be either linked list, array, double-ended queue, or priority queue. So therefore your interface is Q, but the implementation must be one of these three. Easiest one is linked list. Okay. So then the methods are, there's nothing called NQ, DQ in Java interface. So if you want to insert something, you need to say offer. So that means NQ. Okay. DQ is okay, call. Okay, call. Or read or remove. Both are doing the same. One is throwing exception empty, other one is not throwing an exception. Okay, so you can use offer, then call or remove. So that's because that is the names given in Java interface. Okay, offer, call, or offer, remove. Okay. Right, so this is the implementation. I have already done the implementation for breakfast traversing. Right. Breakfast traversing. If root equal null, you return because nothing to traverse. That means you have empty tree. Okay. So then we create a queue object. I use the Java queue and Java queue object. Remember that this is the interface. The implementation must be one of the implementation. So I use linked list because I don't need any special case. Even the priority queue implementation is there, okay, in Java. So then we add the root. We add the root to the queue. As long as my queue is not empty, now we are doing the traversing. What is the traversing? First we add the root. Then we call it. Call it means take it. So that means we add the root and we take the root now. Now actually after this, my queue is empty. So then you visit it. Visit it means you print it. So actually you are printing the root. So once you visit something, you need to add your left child and right child if not null. Of course, if null, don't add it. So therefore we check whether left child is not null. If so, we add it. Then we check whether right child is not null. If so, we add it. So when you visit a node, you need to add your left child and right child if not null. If null, don't add it. And you do this recursive. Right? That's it. Very simple. So then again, you check whether your queue is empty. If you have had at least one child, of course, your queue is not empty. Now again, you take it now, call it, take it out. And when you take it from the queue, you print it. Once you print it, make sure you add your left child and right child of that node, if not null. And you keep doing this recursively. Of course, this is like a recursion because we are doing it in a never-ending while loop. We do it until your queue is empty. Your queue is empty when you have visited all the nodes. Okay, all the nodes. Right. So therefore, for this one, the output will be, I have not enabled the BFT testing fold. Okay. Right. So this is my BFT. Right. So this is the output. Breadth first traversing. Right. So this will be the output. Okay. So you can check that. Of course, you need to recreate your tree again. Okay. You need to recreate your tree. Can I get into that level? No, I don't have that much of undos. Again, recreate your tree and double check. Okay, so this should be the output. Right. So this should be the output after doing. Okay, let's recreate it again and see. This is correct. 55, 80, 30, 40. 55, 80, 30, 40. Seventy, 20, 45. So 70 is already there. Okay. Right. So breakfast traversing result must be what? 55, 30, 80. Let's see the output. The output must be 55. That is the easiest to do. 30, 80. Then next level 20, 40, 70, and 45. This is the last level. This is in the same level. Okay. Let's see whether we get the correct output. 55, 30, 80, 20, 40, 70, 45. Correct. Okay. Right. So that is how you do it. So if you do it by yourself, you will get a lot of satisfaction, confidence, right? So remember, so every day I'm telling this, right? මේ ගොඩක් අය පිළිගන්න කැමති නැහැ. Right? ගොඩක් අය පිළිගන්න කැමති නැහැ. Okay? So you can live in two different ways. හොඳට අහන් ඉන්න. මම හැමදාම කියනවා එක මන්ත්‍රයක් වගේ. හරි හැමදාමත් කියනවා. Right? මොකද මේක තමයි ජීවිතේ. මේක තමයි ජීවිතේ කියන්නේ. So you can live in two ways. That is, you live in a realistic life. යථාර්ථවාදීව ජීවත් වෙනවා. Right? Good life. Right? With your moral values, ethics. That is a choice. Okay? Or else you decide, I live a fake life. Fake life. ව්‍යාජ ජීවිතයක්. Right? That means you are not accountable to your own conscience. Right? You don't have moral values. Okay? You don't have moral values. Right? So that means you try to cheat others. Right? You try to cheat others. You try to lie. That is why you are fake. Right? So that is a choice. Either you live like this way, it's like a binary tree, okay? Live like this way or live like that way. It's a choice that you need to make. Okay. Now, if you decide this type of a life, then you need to act in this way. Plan out, okay, I'm going to have this kind of a life. So now I need to prepare and do it that way. If you decide this way, then you need to plan out that way also, right? Now, if you decide this way, if say you have decided, okay, I need this kind of a life. I'm a realistic person. I'm an ethical person. I don't want to harm others. I don't want to depend on others. I don't want to be a burden to others. This is the hard life. This is the hard way of living. Maybe this is also hard if you don't do it properly. Or sometimes this is the easy way. Okay. And if you decide this and committed to this approach, then when you are doing BIT, make sure you build competencies. Okay. Skills, attitude, ethics, because you are committed to this type of living. If you have decided, okay. So that is during BIT, build these things. If you have decided, okay, I'm going to have this kind of a life, first of all, you have made a wrong decision, right? Doing BIT, because BIT is more for this kind of people. So therefore, already, if you are in this kind of mindset, you have made a mistake also. Okay. But anyway, still make what maybe so then make sure you pass exams. මේගොල්ලන්ට exam pass වෙන්න එපා කියන්නේ නැහැ. Just pass exams also, right? But at the same time, make sure you build this. But here, just pass the exams. දැන් BIT කරන්න පටන් ගත්තා නේද? කරන්න දෙයක් නැහැ නේ. මේ જાති ජීවියෙක් වුණාට. දැන් මොකද ඉන්න තැනින් ආයි format කරලා හදන්න බෑ නේද? දැන් ඉඳලා පටන් ගන්න pass exams. Because ඔයා මෙතනින් success කරන්න හදන්නේ මං. හරි. But don't build competencies. මොකද ඔයා මේ පැත්තට යන්න කැමති නැහැ. Right? Don't think about building competency skills, but make sure you somehow pass exams. Make sure you pass exams, right? Good results and so on. Okay. Then try to utilize it. මොකද ඔය උපාධි වලට ජොබ් දෙනවා. මම කියන්න ඕනේ නෑනේ. සහතිකයට දෙන ජොබ් තියෙනවා. ස්කිල්ස් ඕනේ නෑ. සහතිකයට ජොබ් එක දෙනවා. So then get into that kind of a job. කොහොමද ප්‍රොජෙක්ට් එකක් තමයි කරගන්න බොරුවෙන් හරි. හරි. So get that kind of a job. අපි කියන්නේ පින් රස්සා. එතකොට ඔයාලට guaranteed salary දැන්. ඔන්න දැන් අන්තිමට මාසෙ අන්තිමට salary එකක් එනවා. වැඩ කරත් එකයි නැතත් එකයි, පොල් ගෑවත් එකයි. ඔන්න දැන් ඔයාගේ fake life එක දැන් හරි. මොකද වැඩ නොකර salary ගන්නවා කියන්නේ මොකද්ද? Fake life. Okay. මේක ජඩකම. වැඩක් නොකර සල්ලි ගන්නවා කියන්නේ මම ජඩේක්නේ. තමන් වැඩක් කරාම පඩියක් ගන්නකොට තමන්ට මතක් වෙනවා හරි මම මේ වෙනුවෙන් මීට වැඩිය වැඩක් කරලා තියෙනවා මේ වෙලේ. right? හැබැයි ඔන්න මම මේ පැත්තෙන් සාර්ථක වෙන ඉතින් කියන්නේ. So make sure you somehow pass your exams and somehow get that kind of a job. ඒ වැඩ කරන්න ඕනේ නැති job තියෙනවා. එහෙම job එකක් ගන්න. ඊට පස්සේ job guaranteed. ඒ job වලට ගියාට පස්සේ ආව අයින් කරන්න කිසිම හේතුවක් බෑ කාටවත් මොන జగතේටවත් අයින් කරන්න බෑ. ඔය වැඩ කරත් එකයි නැතත් එකයි. හරි. මොනවා හරි මිනිහම් මරලා වගේ මොනවා හරි වුණොත් තමයි අයින් කරන්නේ. නැත්තම් ඔහේ තැබ්බ වගේ හිටියත් ඉන්න පුළුවන්. right? But others මේ පැත්තට යන්න ඕන අය. ඒ කියන්නේ ඔයාලට කවදා හරි හිතෙන්න ඕන මම productive සාර්ථක මිනිසෙක් ප්‍රයෝජනවත් මිනිසෙක් කියලා හිතන්න ඕන නම් make sure you build your competency skills, right? Correct attitude, right? And so on. So just keep it in mind. So ඒගොල්ලන්ට මම මේ කියන්නේ method එක ලියන්න. හරි මේක අමාරුයි. මේ ජීවිතය අමාරුයි. මේ ජීවිතේ නිකන් මීහරක වගේ ඉන්න තියෙන්නේ ඊට පස්සේ. හරි පඩිය හම්බ වෙනවා, පෙන්ෂන් එක හම්බ වෙනවා. So I recommend you to come to this side. මොකද BIT වලට ආවෙත් IT field එකේ බහුතරය හරි මේ පැත්තේ ඉන්න අය තමයි. ඔයගොල්ලෝ software development company එකට එහෙම ගියොත් ඒක ඇතුලේ පිනට කන්නේ උන් නිකන් කන්නේ උන් බොරු කරන්නේ උන් බෑ. හරි? හැබැයි මෙතන කට්ටිය නවාට හොඳම වැඩක් තුන මීට කලින් කරගන්න. IT කරන්නේ නැතුව වෙන fields තියෙනවා මේ පැත්තේ. මම කියන්න ඕනේ නෑනේ. හරි? තවත් ලේසි ඔයාලට. තවත් ලේසි ඔයාලට. ඔයා දැන් ඒ පොඩ්ඩක් වරද්දගෙන තියෙන දැන්. හැබැයි IT වලුත් බංගු ගහලා එන්න පුළුවන්. හරි? හොඳට මතක ගන්න. හැබැයි ඉතින් මේගොල්ලන්ට මේ ජීවිතේ මේ වගේ සමාජයක තමයි සර්වයිව් වෙන්න පුළුවන්. ඔයාට ඇමරිකාවට ගිහිල්ලා ඕස්ට්‍රේලියාවට ගිහිල්ලා නම් සර්වයිව් වෙන්න බෑ. මොකද ඒ සමාජය ඇතුලේ මේ වගේ වුණා. ඒ මිනිස්සු බුද්ධිමත්. ඒ මිනිස්සු බුද්ධිමත් අන්න මේ වගේ වුණාට chance එකක් දෙන්නෙම නැහැ. හැබැයි ඒත් පුළුවන් අඟු ගහලා ඒ ජීවත් වෙන්න. හරි කොහෙත් ඔය ටක් අඩින්ට ජීවත් වෙන්න පොඩි පොඩි chance හම්බ වෙනවා. හැබැයි හරි අමාරුයි. හරි අමාරුයි කියලා සර්වයිව් වෙන එකලගේ අපෝ මේ ජීවිතේ හරි අමාරුයි කියලා ඇයි ඒ? බොරුවෙන් ජීවත් වෙන්න බෑ. හරි දකුණු කොරියාවට ගිහලා ජපානයට ගිහිල්ලා අඩුම ගානේ අපේ තියෙන එම්බසි එකටවත් යන්න ඕනේ එහෙමත්. එම්බසි එකවත් ජොබ් එක හොයාගන්න. ලංකාවේ එම්බසි එක. මේ සමහර ඉන්නවා එහෙමත් ඉන්නවා. ලංකාවේ එම්බසි එක තමයි ජොබ් එක. අපි බලමු අපෝ මූ කොහොමද මේ ජීවත් වෙන්න සර්වයිව් වෙන්නේ කියලා. ඔයලා බලමු ඌගේ ජොබ් එක ලංකාවේ එම්බසි එක. ආයෙ එහෙනම් පුළුවන්. එහෙනම් පුළුවන්. නැතුව ජීවත් වෙන්න බෑ මේ ටොයෝටා කම්පැනි වැඩ කරලා. හරි. ඒ විදිහට. So just plan out your life, okay? Plan out your life. Right. So now we have done the traversing part as well. Okay, traversing part is also done. Deleting a node. So that is our next one. Deleting a node. So මේගොල්ලෝ සතුටු ලබන්නේ කොහමද? මේ වම් පැත්තේ සතුටු වෙන්නේ මොනවාද? යමක් කරාම problem එක solve කරලා සතුටු වෙනවා. right? problem එක solve කරලා සතුටු වෙනවා. අමාරු දෙයක් කරලා සතුටු වෙනවා. So they achieve something, right? අරගොල්ලෝ සතුටු වෙන්නේ මොකටද? මිනිස්සු රස්සියාදු කරලා මිනිසුන්ට ජීවිතේ එපා කරවලා සතුටු වෙනවා. ඒගොල්ලෝ සතුටු වෙනවා. සැලරි එකක් ගත්තාම බුදු විදියට සතුටු වෙනවා. හරි. ඒගොල්ලෝ එක සමාන ජීවිතේ එක සතුටු වෙන එකම දවස් තමයි පඩි හම්බෙච්ච දවස්. මොකද අනිත් දවස්වල සතුටක් නැහැ නේ. සතුටෙන් බොරු කියක් කරන්න බෑ. So just keep that in mind, okay? Right. So now we are into the deleting nodes. හැබැයි IT කරන අයගෙන් බහුතරය ඉන්නේ වම් පැත්තේ කියලා මම දන්නවා. හරි. ඔයගොල්ලන්ගේ බහුතරය ඉන්නේ වම් පැත්තේ. ඔයගොල්ලන්ට එහෙම වම් පැත්තට එන තමයි ඔයගොල්ලන් ආසාව තියෙන. ඒ කියන්නේ IT කරන්න පටන් ගත්තේ. ඒක ඉවෙන් වගේ වෙන දෙයක් හරි. අණුව ඇදෙන්නේ අසූචි කොටට. IT පැත්තට එන අඩුයි එහෙම අය. හැබැයි මේ අතරත් ඉන්න පුළුවන් එක්කෙනෙක් දෙන්නෙක් හරිය. හැබැයි මේ පැත්තට ඇවිල්ලා ওই දෙක අතර වැනි වැනි ඉන්න බෑ. හරි. ඒකයි මම කියන්නේ IT කරන්න ආව නම් මේ විදිහට ඉගෙන ගන්න. IT කරන්න එපා දොස්තරලාගේ විදිහට. හරි. ලෝයර්ස්ලාගේ විදිහට. මොකද ඒගොල්ලන්ට උපාධිය ගත්ත ගමන් පඩි හම්බ වෙනවා. පඩියක් හම්බ වෙනවා. වාහනයක් හම්බ වෙනවා නේද? දොස්තර කෙනෙක්ට නේද? ලෝයර් කෙනෙක් නම් නිකන් හිටියත් ඔය ඔප්පල් ලියුම ලක්ෂ ගණක් හම්බ වෙනවා. එහෙම පඩි හම්බ වෙන්නේ IT කරන්න අයට. ඒකයි මම කියන්නේ මේ පාත් දෙක තෝරගෙන හරියට යන්න කියලා. හරි මේ දෙක අතර වැනි වැනි ඉන්නත් බෑ. එහෙට වැනෙනවා මෙහෙට වැනෙනවා ටිකක් නේද? IT කරනවා හැබැයි කරන්නේ දොස්තරගේ මානසිකත්වයේ. උපාධිය ගත්තා මට රස්සා දෙයි නෑ. එහෙම රස්සා දෙන්නේ නෑ. ඔයාලට එහෙම මේ රස්සා දෙන්නෙත් නෑ. ඔයාලට එහෙම වාහනයක් ගන්න පර්මිට් එකක් දෙන්නෙත් නෑ කවුරු. ඒකයි කිව්වේ හරියට යන පාර දැනගෙන යන්න කියලා. හරි. නැත්තම් මම්මුලා වෙනවා ජීවිතේ. මම්මුලා වෙනවා. අන්තිමට ඔයාලා කල්පනා කරන්නේ අපෝ මට මොකද්ද මේ වුනේ කියලා. ඒකයි කියන්නේ දැම්ම එක්ක IT නවත්තලා යන්න ඒ පැත්තකට. එතකොට මම මේ කියන්නේ දොස්තරලා නරකයි කියලා නෙමෙයි දොස්තරලාගේ දෙගොල්ලෙක් ඉන්නවා IT වලත් දෙගොල්ලෙක් ඉන්නවා ලෝයර්ස්ලාගේ දෙගොල්ලෙක් ඉන්නවා මම කියන්නේ මේක ප්‍රොෆෙෂන් එක නරකයි කියන එක නෙමෙයි හරි හැබැයි බහුතරය නේද එහෙනම් අපිට අයිඩියා එකක් තියෙනවා දොස්තරලාගේ බහුතරය හැසිරෙන්නේ කොහොමද ඉංජිනේරුවන්ගේ බහුතරය හැසිරෙන්නේ කොහොමද IT ෆීල්ඩ් එකේ බහුතරය හැසිරෙන්නේ කොහොමද හරි ලෝයර්ස්ලාගේ බහුතරය හැසිරෙන්නේ කොහොමද අපි දන්නවා ඒක අපි දන්නවා ඒක මොකද අපිට බොරුවක් ලියවම කෝඩ් එක බග් right? If you're a software engineer, if you make a lie, right? So that QA fail, right? You can't survive. හැබැයි ලෝය කෙනෙක් වුණා ඔය බහුතරේ 150 කියන්නේ බොරු නේද? දෙපැත්තක් ඉන්නකොට දෙපැත්තම හරි නෑ. ඒතකොට එක පැත්තක ලෝය කෙනෙක් හරි කියද්දී අනිත් පැත්තේ ලෝය කෙනෙක් බොරු. ඒක ඇත්ත. දෙපැත්තම හරියන්නේ නැහැ නේද? මිනිමරුවගේ පැත්තට කතා කරනවා කියනවාද? ඔයා ගිහලා බොරු කියනවා. ඒකට වඩා පට්ට විදිහට සල්ලි දෙනවා. අපිට නම් කීයක් දුන්නත් ඒ වැඩේ කරන්න බෑ. හිරිකිතයි. Because our culture is different. ඒක හරියට ඉවරගෙන ඒ හිරිකිත නැත්තම් නේද? දැන් අපිට සතෙන් මරන්න බැරිනවනේ සත්තු මරණේ උන් ඉන්නව නේද? බුච කෙනෙක් වෙන්නේ නේද? එයා සත්තු මරනවා. සමහරට ඒ සත්තු මරණ සත්තුම කනවා අනිත් කට්ටිය. එහෙම තමයි ලෝකේ. ලෝකේ සර්ව සාධාරණ නැහැ. සර්ව සම්පූර්ණ නැහැ. But you can decide what is the life you want to live. Right? What can you tolerate? සමහරවිට බොරු කියනකොට හරි ස්ට්‍රෙස්. සමහරවිට බොරු කියන එක විනෝදයක්. සමහරවිට ජරාවක් කරනවා, පගාවක් කරනවා, තව කෙනෙක්ව අමාරුවේ දානවා කියන්නේ හරි ස්ට්‍රෙස්. නෝ තව කෙනෙක්ට බොහොම ලේසියෙන් මංකොල්ල ගන්න පුළුවන් අනුකූලව නේ. hina යන්නේ උසාවියේ ඉඳලා. So that is your personality, that is your character. Right? That is your class. Right. So now we are into the deleting of a node. Deleting of a node. So how do you delete a node in binary search tree? Remember, we are in binary search tree, okay? Binary search tree. So it's a little bit complicated, but it's not rocket science. Okay. So we can identify 3 scenarios. What are those 3 scenarios? Number 1, node to be deleted is a leaf node. That is the easiest to implement. Number 2, node to be deleted is an internal node. That is not a leaf node, but it has only one child. That is also not that difficult. Okay. So the third scenario is node to be deleted is an internal node, but it has 2 children. So that is where you need to be a little bit careful. Of course, all 3 you need to be careful, but so once you isolate it to these 3 categories, scenarios, we can come up with logic. Okay, so let's take one by one. If your node to be deleted is a leaf node, simply you delete it. Remember, the idea is you delete the node, but preserve your binary search tree nature. That is, your tree is still sorted from left to right. Okay, left to right. So this is an example. Say I want to delete, say 85. Okay. And of course, 85 is a leaf, no children. So how to delete it? Simply delete it. So what is mean by deleting it? Can someone tell me what is mean by deleting this node? Now, communication skills, your logical thinking. Can someone tell me in simple English, what is the meaning of deleting this node? Or how to delete this?
Previous left node is equal to null.
Can you repeat it?
Previous left child node equal to null.
Yes. So the previous node, so its parent nodes, left child set it to null. It's almost there. So how to delete this node? Go to its parent node, and if you are the left child, make sure your parent's left child is null. And if you are a right child, make sure your parent's right child is null, and that's all. That's all. That means you have deleted. It's super easy. Right? Say you want to delete this. It's a leaf node. Check whether you are the left right child or right child of your parent. If you are the left child, make sure your parent's left child is null. Simple as that. Okay, so maybe you can implement this by yourself. It's a good challenge. Try to implement the delete node functionality for all 3 scenarios. All 3 scenarios. It takes time. Maybe it will take half of your day. Half of your day. Not, this is not because it's coming for your exam. You want to build your competencies, build your confidence. Okay. Right. So that is scenario 1, right? So that is the easiest scenario to implement also. Your implementation also, you can take it to 3 cases, 3 scenarios and implement, but in the same method. Because when you delete, it's delete. Right. So that is your scenario number one. Right. If you are the leaf node, set your parents' relevant child to null. Relevant child means if you are left, make left child null. If you are right, make right child null. And it's very important that you have good communication skills. Right? Good communication skills. So communication skills also හැම දෙයක්ම වලට දෙවිදියට පාවිච්චි කරන්න පුළුවන්. හරි. So if you have good communication skills, you can use it for good things. If you have good communication skills, you can use it for bad things. So that is what we do, right? So as software engineers, we use it for good things, right? So that is why we say simple, short, clear, relevant. That is for engineers, especially for programmers. Simple, short, clear, relevant. So assume that I am a lawyer, you have done a serious offense, right? Murder. ඔයාම කියනවා මට ඇවිත් මම තමයි මැරුවේ. Okay. Or you have done a serious bribery, corruption. ඔයා කියනවා මම තමයි මම එදත් චරාවක් ගත්ත පගාවක් ගත්ත දැන් මම බේරලා දෙන්න මම අල්ලගෙන දැන් පොලිසිය. Bribery, corruption. So now what? දැන් මම කියන දේ සරලව කෙටියෙන් පැහැදිලිව explain කරනවද? බෑ. දැන් මම මොකේ අනිත් පැත්ත කරන්නේ? මම මේක අවුලවනවා. මේක confuse කරවලත් මෙයාව කොහොම හරි කොට දාන්න දැන් සාකි බින්දින්න හදන්න. ඒකට ඒකට මට සල්ලි හම්බ වෙනවා. ඒත් මම රැට කල්පනා කරනවාද මේකට ගහන බොරුව මොකක්ද? right? කොහොමද දැන් මේක මේ සාක්කිය බොරුයි කියලා ඔප්පු කරන්නේ? මේ ඇත්තටම දන්නවා මේක ඇත්තට සාක්කියක් කියලා. So that is what my job is, right? That is my job is. If I am willing to go into that level, but not every lawyer is like that. So there are some lawyers, they will say, okay, I have make a පිළිගන්න. මම එන්නම් ආයෙත් එන්නම්. හරි හැබැයි මම එනවා ආයෙත් උසාවියට හැබැයි මේක පිළිගන්නවා. ඒවා වැරද්ද කරා. සමහරවිට අපි පොඩි ජස්ටිෆිකේෂන් එකක් දෙමු ඔයාලට මේ ප්‍රශ්න හන්දයි ඔයා මේ වෙලාවේ හැසිරුනේ. Right. So therefore here your task is make it simple, short, clear communication. So that is what you are doing, right? Programming is communicating your solution to the computer. So that is why I'm asking you to explain it in simple English. Okay. Right. So that is when your node to be deleted is the the leaf node. So the second scenario, the node to be deleted is an internal node that is not a leaf node, but that node has only one children. That means that children can have other children and so on, but you have only one path. That is also not difficult to handle. Right? That is also not difficult to handle. How to do that? Right? It's something like you want to delete this. Now you can see this is not a leaf node, right? But you have only one child, not two. Something like this. You want to delete this, but you have only one child. Okay. Or something like this. So that one doesn't have to. So assume that this one does. This is not. This is also like that. You want to delete this, and you have only one child. Assume there's nothing like that. How do you delete these kind of scenarios? This kind of. Assume there's nothing here. Okay. So this is also very easy scenario. What to do? If you want to delete this, and if you are the right child of your parent, make sure your child is the right child of your parent. ඒ කියන්නේ ඔයාගේ ළමයාව බලා ගන්න දෙනවා ඔයාගේ අම්මට හරි තාත්තට. එතනදී එක්කෙනයි ඉන්නේ. හරි ඔයාගේ parent එක්ක දෙනවා ඔයාගේ දරුවව බලා ගන්න කියලා එක දරුවා ඉන්නවට. එයාට දරුවෝ ඉන්න පුළුවන්. හැබැයි එයාගේ left ඔයාගේ දකුණ නැහැ. ඔයාගේ දරුවව දෙන්නේ දකුණේ දරුවා විදියට. So if you are the right child, you must assign your child as the right child of your parent. If you are the left child, make sure your child is the left child of your parent. It doesn't matter whether your child is left child or right child, but you just need to check what is your connection. If you are the right child, your child is the right child of your parent now, because you are going to vanish. You are going to vanish because you will be deleted. ඒක හරියට තමන්ගේ දරුවෝ ටික දෙනවා අම්මට අනේ නැත්නම් ආච්චිට දෙනවා සීයලා දෙනවා අනේ මේගොල්ලෝ බලාගෙන මම මැරෙනවා. Okay. So therefore, this 35 will come here. So this 35 will come here. Here, if 80 is going to be deleted, then 90 will be the children of 45. That's it. And it still preserve the binary search tree. Okay. So that is how you delete it. Right? Then make it logically and because you want to double check whether you have only one children. And then you need to check whether are you the left child of your parent or right child and do it. But this is not rocket science. Make a liyanna පුළුවන්. Right? ලියන්න බැරි කමක් නැත. Right? මේකද අපි ලියලා තියෙන logic. Software developers. දැන් ගෙදර සෙල්ලම් බඩුව සෙල්ලම් කාණු හදුවාගේ නෙමෙයිනේ නේද? වික්ටෝරියා වේල්ල හදන එක. ගිහලා හයි කරන් ලොකු windmills මීටර් 400ක් විතර උසයි. ඔය හයි කරන්න. So that is where we need courage, willpower, perseverance. Right. So that is how you do it. Okay. So if you want, you can do it. But හැබැයි දවසක් හරි ගන්න බලාගෙන වැඩේට වයින්න ඕන. කෝඩ් කරන්න. හැබැයි හොඳට ටෙස්ට් කරන්න එක scenarios එකකින්. මම කියන්නේ මේක හැමෝටම කරන්න කියලා, right? If you want to be a software engineer one day, it's a good thing to do. If you want to be a software engineer. There is another issue with BIT degree program. Right? So remember there are some degree programs, even in UCSC, Bachelor in Software Engineering. Bachelor in Software Engineering. So then, of course, they are committed to software engineering, right? Put software engineering degree, software engineering. So these guys are very committed. But when it comes to BIT, the biggest issue we are having is, right? So I'm a very realistic person. And මෙතන ඉන්නවා එහෙම software engineers ලා වෙන්න අකමැති, IT professionals ලා වෙන්න අකමැති. හැබැයි IT degree එකක් කරන කට්ටිය. හැබැයි එහෙම කට්ටිය හරියට software engineers degree එකක් ඇතුලේ. medical college එක ඇතුලේ ඉන්න 95%ක්ම doctors ලා වෙනවා. 5% විතර තමයි doctors ලා වෙන්නේ. engineering faculty එකේ civil engineering department එකේ ඉන්න 95%ක්ම civil engineers ලා වෙනවා. ටිකයි එහෙම නොවෙන්නේ. හැබැයි BIT degree එක ඇතුලේ ඉන්නකොට සමහර 150ක් විතර ඩිග්‍රී එක අතරමක IT ෆීල්ඩ් එකෙත් නෙමෙයි. ඒක අර අපිට අර ඒ කල්චර් එක නැත්තේ මෙතන. හරි? ඒ කල්චර් එක නැත්te. කියන්නේ අර නිකන් අර අපි කියන්නේ අර සුළඟේ පාවෙලා එන කට්ටියත් BIT ඩිග්‍රී එකට එනවා. හරි? නිකන් හුලකට රැල්ලට. එහෙම නෑ අර අනිත් තැන්වල. එහෙම අනිත් මේ ගානත් අඩුයිනේ. දැන් ස්ලිට් එකට ලක්ෂ 15ක් විතර දෙන මිනිස්සයා බලන්න කොහොමද ලක්ෂ 15ක් විතර දෙන්න කලින් මට ඇත්තටම software engineer කෙනෙක් වෙන්න ඕනද? ඇත්තටම data scientist කෙනෙක් වෙන්න ඕනද? නවන් මේක රුපියල් 25000 35000 ඉස්සෙල්ලා semester 1 විතරයි කියලා කරනවා නේ. එහෙම බෑ. Right. So this is for those who are really serious. Right. So implement this. Right. If you are not very serious, find your way. ඔයාලා දැන් විතර plan කරන්න ඔයාගේ life එක මොකක්ද? හරියට software engineer කෙනෙක් වෙන්න නැත්නම් IT professional කෙනෙක් වෙන්න නැත්නම් මම කවුද වෙන්නේ? හරි. මම business පැත්තට යනවාද? accounting පැත්තට යනවා. හැබැයි සමාජයේ වැඩක් තියෙන වැඩක් කරන්න හරි බොරු නම් කරන්න එපා. එන ගහනවා. Tamanටම එන ගහයි. බොරු කරලා පඩි අරන් ගියොත් එන්නේ. Tamanටම හිතේ තමන් මොන නරුම ජීවිතයක්ද ගත කරන්න කියලා. කවදා හරි. Right. So that is the scenario 2. If you have the willpower, you should be able to implement it. And you will learn a lot of things while implementing that method. Right. So scenario 3. So this is one child scenario again. And you just make this guy, right? So 90 is your parents, right children, right child. Okay. Right. So the scenario 3. Scenario 3 is you want to delete a node and that node has 2 children. Right. So that means you want to delete the internal node. And that node has 2 children, like this. You can see 4. You want to delete this, you have 2 children. So now how do you do that? at first you might find it difficult, but there's a logic. So this is how you do it. Right? Say you want to delete this. Remember, at the end, you must preserve the binary search tree nature. So this is the logic we use. First, double check whether you have two children. Yes. So then you find what is known as in-order successor or in-order predecessor. Just one of those. Right? Say you want to find in-order predecessor. So that means, so this is the one you want to delete, right? You go one right, just one right, because remember you have two children. So therefore, always there's a right child, always there's a left child. So this is, I'm explaining how to find the in-order predecessor. You go one level right, then you keep coming left. If there's nothing to go left, that is your in-order successor. You go one right and then keep coming left. If there's nothing to go left, that means you are in a node and there's no left child, so that is your in-order successor. So then replace your node, because you are going to die, with that in-order successor. So that means 82 comes here. Okay, 82 comes here. And that's it. And of course, then this will be connected to this one. That is why it's difficult. Now, when you take this, now if that one has children, now you need to connect that. So this is the most difficult scenario to implement. Okay, this scenario, because then you need to connect that one also as the because you are going to delete this one, right? So then this must be the right child of this. So if you have both, right? Both, of course, you can't have both because then it is not the in-order successor. Always you have either right or left. So then if you are looking for the in-order successor, make sure your right of that node is the left of this. Okay, because there's no way you can have two children, because then of course this is not the in-order successor. That means you can go further. Okay, but still you should be able to implement this. Okay. Nice. So that is how you do it. So then you replace that with this and make sure you do the adjustment here also. So you need to replace this with this and do the adjustment here. මෙන්න මෙතනයි වල පොඩි වැඩක් කරන්න තියෙන්නේ. මෙයාව හරියට ඇඩ්ජස්ට් කරලා දාන්න. ඕක මහ වැඩක් නෙමෙයි හරි. ඔළුවට ආවට පස්සේ විනාඩි 5න් ලියන්න පුළුවන්. Okay. ලොජික් එක හරියට ඔළුවට ගත්තා පස්සේ විනාඩි 5න් ලියන්න පුළුවන්. in-order access වෙන එක මහ වැඩක් නෙමෙයි. මෙයාගෙන් එකපාරක් right දීලා දිගටම left එක null වෙනකන්, left child null වෙනකන්. So then you do this replacement. Okay, so this is the replacement. You can see now 80 will be replaced by. So this is if you are doing going with the left. Okay, this way 82 is going to replace your 80, and then 84 need to adjust as the right child of 85. So now we are done. Now it's again the 80 is deleted and it is again sorted from left to right. Okay. Or else, both work. Or else, you find in-order predecessor. So that means here, right? So if you are in the left side, sorry, right side, you need to find the in-order predecessor, right? But if you want to delete something in the left side, this is when you are in the right side of the rule. If the node to be deleted is in the left side, then you need to find in-order successor. This is in-order predecessor. මෙහෙම ගියා මෙහෙම ගියා. මෙහෙත් වෙන්න ඕනේ අර වමට ගිහිල්ලා දිගටම දකුණට යන්න. වමට ගිහිල්ලා දිගටම දකුණට යන්න. So then that node must be replaced with that one and do the adjustment. Okay, so let's take an example. So let's say we have one more node here. Say 22, right? 22, and you want to delete, right? So then you have 23. Okay, right? You want to delete 30. Okay. So one solution is you replace this with 40. So 40 comes here because, sorry, one solution is you go to right once and go left. When you go right once, then there's nothing to go left. So therefore you are in the in order successor. So then you replace this with 40. But that doesn't work, right? Why? No, that work, right? Yes, that works. So therefore, yes, you can do either in order successor or in order predecessor. So that works, right? Because 40 is bigger than 20. And of course, 25 is smaller and so on. Yeah. So, or you can use in order predecessor. So that is, rather than you go to right and keep going left, you go to one left and you keep going right. You come one left and keep going right. There's nothing to go to right. So then this is you replace with this one. That also work. Both work. Okay. So I'll again explain here. So you want to delete. Say there's another one here. Say 48. So you want to delete this. One option is you go to one left and keep going right. So therefore 82 is replaced with this. Other one is, right? Other one is now you want to delete this. You go one left and then keep going right. But nothing to going right. So therefore you have already there. So then you replace it with this. Both work. That means either you replace it with in order successor. That means go one right and keep coming left. Or in order predecessor, that means you go one left and keep coming right. And when you don't
So
have,
then when we are doing like that, we have to check with the root cause, whether it is okay.
no, you don't need to check the root because root is also this kind of scenario now. Scenario 3. Right? For example, say you want to delete the root now. So either you use in order successor, in order predecessor, right? So let's say we want to find the in order successor. So you go one right and you keep coming left, nothing to come. So therefore you can simply replace 45 with 50. 45 with 50. Right. So
Okay.
then this is your 50 and 90 will be connected to this. Okay. So that is 10, 20, 25, 30, 45, 40, 50, then 82, 84, 85, 90, 95. Correct. Or else you find go one left and keep coming right. Keep coming right. Nothing to go right. So therefore you can replace this with 40. That is another solution. Both work. Because now you can see 10, 20, 25, 30, 40, okay, 40, then 50, sorry, not 50. How can you have 50 here? Yes, 50 is here because these are right. Right. So those, they look like in the left side. Actually, those are in the right. Yes, correct. So therefore, you go this way one times, and then you keep going right, and there's nothing to go right way. So therefore, you delete this and put it there. Now it's correct because 10, 20, because 25 is right of that. So then 30, and this is not there. Then 40, right? So then 50. Then 82, 84, 85, 90, 95. Remember this 82, though it looks like it's in the left, but actually it is in the right because it's in the right side. So therefore, this is also, so therefore, in order successor, right order successor, anyone is going to work. Any replacement is going to work. Okay. Right. So that is how you delete. Okay. The three scenarios. Right. So where do we use binary search trees? As the name says, if you want to search something fast, right? Search something fast, you can put it into binary search tree, and then search it. Because when you are in binary search tree, right? For example, say you are searching for 84, maximum how many steps you need? 1, 2, 3, 4, 5, you are found. So the worst case is also log 2n. Log 2n. Right? So how many elements we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Log 2, 12. So that is log 2. The nearest one is 16. That is 2, 4, 8, 16. 2 to the power 4. Okay. So 2, 4, 2, 4, 8, 16. Yeah. So the next one is 16. So it's 4. Right. So 1, 2, 3. No, it's not 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, log 2n, right? Okay. Log 2n. So why we have to go for 1, 2, 1, 2, 3, 4, 5. But what we have is 4, right? Why is that? Let me double check, okay? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, let me double check with ChatGPT whether log 2n. It should be log 2n. Is it n log 2n? No. What is the worst case? We are interested in worst case. It must be balance, I think. Performance of binary search tree. Yeah, this is if it is balanced, okay? Otherwise, it will be bigger than log 2n. Search. The worst case performance of operation on binary search tree depends on whether it's balanced or not. That is why I told you, right? Right. Now, if it is balanced or not, it depends. Okay. So this is, if it is balanced, log 2n. Actually, this one is not balanced. That is why I got more than log 2n. Okay. This is not balanced tree. So if it is balanced, anyway, balanced binary tree is our next topic. Okay. If it is balanced, the worst case also we can do it in log 2n. Right, log 2n. Right, search, insert, delete, because delete and insert is pretty much like search. But if it is not balanced, it can even go for ON. Because remember, though you create a binary tree, you ended up in a linked list. Right? I told you, right? Though you create a binary search tree, you can ended up in a linked list. Okay, let me open it again. Right, so then you can't say that is log 2n. It is actually ON then. So the worst can go up to ON if it is normal tree, because though you try to create a binary search tree, you will end up as a linked list. Right? For example, if you are inserting this kind of data, say 10, 12, 15, 30, 40. Now, first one is your root, right? So next one is bigger than this. 15 is bigger than 10, bigger than 12. So you will end up as a linked list. So therefore, now you can't say that when you search 40, how many times you need? 1, 2, 3, 4. Right? That is, if you start from here, 1, 2, 3, 4, 5. And when you have 5 data, you need 5 attempts. So that is why we say worst case is ON if it is not a balanced binary tree. Because the worst scenario is you try to create a binary tree but your binary search tree ended up as a linked list. But if it is balanced binary tree, yes, your search is ON, which is much better than, sorry, your worst case performance is log 2A. Log 2A. Okay. Okay. So this is the biggest usage of binary search tree, because when you put it into our search tree, binary search tree, especially if it is balanced, the worst case also you can search it in log 2n time. Okay, log 2n time. Is it clear? Right, so what is the time now? Right, so we'll stop at this point because in the evening session, we will continue this. We will continue this and finish. Basically, we need to do the balanced binary search tree, the AVL tree, and then we need to do the binary heap, which is the binary search tree is related to binary search. Remember, we have to do the search and sorting algorithms last topic. So therefore, now we are gradually into the searching and sorting also, because binary search tree is related to binary search, and binary heap is related to heap sort. Okay, then අපි ටික ටික final topic එකක් cover වෙනවා මෙහෙම. හරි. Right. So we'll stop at this point. So the evening session start at 7. So in the evening session we can finish trees. Okay. And also we'll do the past paper. I gave you the question numbers for the data management. Okay. Right. We'll stop at this point. I will give you a separate invitation for the evening session. Okay.